The Earth is very flat.
What's going on, everybody? It's Thursday, June 17th, 2021. It's Brandon, host of Brandon Show. How's it going, everybody? We've got Paul Cruikshank. What's up, Paul? Gadget Inspector. Bill G. Says, I use GPS to dilate time and give you your sound check early. Thank you. Sound is good or was good? We'll go with is. Helen Degenerates. White's Word. Taking Back Eden FE. What do you got here? Website www.dissentfromdarwin.org. Have to check that out. PhD holders are now skeptical of evolution, including 120 plus patent holder. Former scientist of the year, former blank churned blank chemist James Tour. I'll skip that one part just for YouTube's sake. Let's see what else. Who else? Enigma. Enigma was first. Second best, Bob. Page 42. What's up, guys? How's it going? Good, good. Sound check is good in present time as well, or possibly in the future. All right. What do we got going on tonight? We didn't have a show last night, so we should do the first half without any ballers. We'll see what happens there. Maybe we'll do that. I don't know. And what else? Nothing. If you saw the thumbnail, there was absolutely nothing behind it. I just thought that picture was very funny because Neil deGrasse Tyson looks like a complete boob in it. And I think that's pretty hilarious. Let me open it up and I'll show you guys. For those of you who didn't see the thumbnail, I don't know if it comes across or not. Let me see here. Here we go. Hold on, I'm clicking files. I found this on a channel that I just came across. It's called, oh shoot, I want to get the name right. Let me look this up. But anyway, this channel, I'll tell you the name here in a second, has got some pretty good content. I can't tell if the guy is a flat earther or not, but he breaks down flat earth arguments and does true crime too. So if you're into true crime, it's pretty cool. And I'll find the name. Mind Shock. I've been listening to a bunch of his videos because I get into true crime, and he broke down Neil deGrasse Tyson and what's his face, Rogan, and then he broke down Rogan versus Eddie Bravo, that old one where Eddie Bravo was talking to Joe Rogan about flat Earth. That was pretty entertaining. He did like a 6-part breakdown of that. Goes over the logic and the fallacies and all that stuff. Pretty good stuff. Check it out. Mind Shot. And I saw this picture on one of his videos. Like, oh my gosh, I love it. Anyway, we got a few people in Discord. We can go and see what they're talking about and get started. What's going on, guys?
Hey.
Hey. Got Crit, Aaron, Farming Ganja, Jeremy, and Rob. What's going on? How are you guys doing?
What up? What up, Brandon?
What up? How is everyone?
Hanging in.
Hot.
Yeah,
Huh?
here too.
Oh, hot. Where are you? What are you guys? Down south or what?
No, northern Minnesota.
What?
Yeah, it's like, look it up. It's crazy hot. It's broken every record for like a week straight. Then there's one day it dropped down to the 60s and went right back into the 90s again.
Holy shit! Yeah, it's like 82 here, but I see that it's 90 in Chicago. Must be a heat wave over there.
Yeah, it's going like a band, kind of like all the way through.
The news is calling it a heat dome.
A heat dome? I didn't see that.
A heat dome. Look it up. Yeah, it's funny as shit.
Everyone's, even like the neighbor who's like keeps his lawn like a golf course. It's all brown and everything.
Yeah, it's like perfect here. 82, a little breezy. Love it. Maybe that's headed my way though. Anyway,
Yeah.
what's going on, Aaron? Don't see you around here much these days. What have you been up to, man?
I've been on just in the background, quiet. I think I get my fair share from time to time at later hours of the night.
Oh, the after show. Yeah. Anybody wants some entertainment? Stop in here when Aaron and Bance are, pretty funny from time to time. We got Adam Meekin stopped in. What's up, Adam?
Evening, Brandon. Yeah.
Evening.
Just having a little tiki whiskey before bed, so I thought I'd just listen and see what's going off. I was going to say listening, not necessarily have to speak, but yeah, evening, dude.
Good evening. And Jeremy? What's up, Jeremy? Maybe he's in a meeting.
How we doing?
There he is.
Somebody overtalk him real quick.
Why?
Just to get the show started right, bro.
Don't get me all fired up. I'm nice and calm right now. I'm sure Rumpus there's some
There we go.
Said it's not Friday, is it?
Yeah, it's not Friday. No, it's Thursday. But
Man, earlier in the week, the Bev cult had all the globalists all worked up. Man, they were in here for almost a solid 24 hours just shit talking each other.
What?
Man, Bev brings out the best in everybody here.
Yeah, like the last time you did the show, you had, was it, or 2 days ago, or 2 times?
Oh yeah, Tuesday. Yeah.
Yeah, so Bev was on that, right?
Yeah.
Okay,
With his
the after
picture.
show went all the way until like the next day.
You know what? I left the recorder on. I think I have that whole thing recorded then.
It finally broke down because Ed just kept barking at Bev until Bev said, "You know what? I'm done. I'm out of here."
Like barking like a dog?
No, like he said, he kept saying, "Show and tell, Bev. Show and tell. First you show, then you tell." And then Bev would try to explain something, and he would say, "Show and tell, Bev." Okay, Bev, deaf Bev, show, then tell. You know, it just turned into that. Those two just kind of talk over each other.
Oh boy. Huh. Yeah, Bev knows Bev is good at getting under people's skin. I don't know if it's on purpose or if it's just his personality. But
Well,
it
it's
is
kind of
pretty
his
funny.
goal, right? Like that's what he wants to do.
Bev's my friend. I'll say it's a half and half.
Oh, that's funny.
He knows how to get under the skin of people that are being retarded.
Okay. Gotcha. Well, we know we have plenty of that going around. We got James Richard joined. What's up, James?
Just sitting out on my balcony, pushing 105. It hit 107 yesterday.
Holy
Are
crap.
you the one that going on about the eclipses?
I don't think so. Why? What about it?
Okay. No, I
talked a little on it.
Hey James, if you don't mind saying where you at?
Grand Junction, Colorado.
Oh, okay, so you're not under that heat dome that they're talking about.
105 in Grand Junction? Holy crap.
Yes, sir. With cloud cover as well.
Wow.
Well, it was originally a desert.
Oh no, you are. Yeah, it does extend to you.
Huh.
Yeah, Heat Dome 2021. Heat Dome expected to set all records.
What are they blaming it on? Are they,
So we
are
got
they
a
blaming it on
temperature
global
dome.
warming?
Yeah, global warming.
They're talking high pressure from the Gulf of Mexico. That doesn't seem like a good enough excuse, though, right? Because that would just
Yeah, I don't
Oh,
get
the
it.
gas
Wouldn't
is
that
trying
happen
to-
all the time?
The gas
Yeah.
is trying to reach equilibrium. That's a shocker.
Right.
But yeah,
But
that's
I don't get it. Why does it go in different patterns? They have like this, I don't know, shit about meteorology.
Yeah, I feel like
so
they're
I'm
just
sure it
gonna
sounds
blame
stupid.
global warming, right? It's global warming that's doing this.
Well, they can make anything up,
Yeah,
right?
absolutely.
Well, have you ever noticed that when it's cold, they say, well, that's just the weather. But when it's warm or hot or there's droughts, they say, oh, it's global warming.
Yeah, whatever. As usual, they take anything that happens, and if they can use it as evidence to support their agenda, then they'll do that. That's what always happens.
Yeah, not to be like politically incorrect, but when I was a kid, they just called it hot.
Yeah, heat wave.
Yeah,
it's gonna.
it was like, wow, the weather's hot. And
And
if
I
it was
think,
unseasonably hot or unseasonably cold, you just said, there's other things they called that too. But
yeah, like a heat spell or whatever. It happens, right?
But when you were a kid, they didn't even have radio yet. So
yeah,
A lot of the records, some of the heat records that are being broken though, are from like 1913. So
well, since the beginning, yeah.
you
Yeah,
know,
since the beginning, they said there's never been this, not only this temperature for these areas, but this many consecutive days in a row too.
yeah, that could be. I was just talking about the record breaking, and it was 108 instead of one. The high temp was 107 or something. They're like, oh, we broke the record from 1913. Like,
Yeah, like
okay.
here, yeah, like here in Minnesota, they said it has gone in the triple digit temperatures, like 101, 102, but never for 7 days straight. Like
yeah, that seems a little excessive for anybody who's lived up here in these northern
Yeah.
states.
yeah, I guess they're
Oh,
saying that the dome is covering almost all of America. It's like Louisiana and parts of Florida that are outside of it, and then Oregon, Washington, Nevada, California, and then a little bit of Ohio or Idaho. I'm sorry, Idaho.
Idaho, Montana. Yeah, I guess it's they're reaching records everywhere, but it kind of goes to that cold spell. Remember we had down south, I guess here in Texas, where we broke freezing temp records, but never for consecutive days, like you're saying.
Yeah, yeah, that was just this last winter too, where it got so cold that people were having to flee because it was like rupturing pipes and stuff.
Yeah, oh yeah, in February.
See, I got my own reasons why it's heating up. Might sound just as absurd as theirs, though.
Well, go for it.
There's the fifth angel's pouring its bowl out on the sun, and they're calling it global warming.
Huh? What does
Yeah,
that mean?
for tribulation.
Yeah, the fifth angel, when the fifth seal.
Oh, it's a biblical reference. I gotcha.
And then they just blame it on me.
Yeah, might as well. And blame it on whatever you want, yeah. But I wouldn't be surprised if this is because of some of the shit that they're doing with the geoengineering crap. They're probably screwing something up. Who knows?
Yeah, they say that they're spraying metal to reflect the sun's heat, but you would think that if there was tiny metal particles in the air, it would absorb them.
Well, and it's summertime throughout the whole northern hemisphere, quote unquote, sphere, but it just seems to be happening here.
Yeah, that too about the global warming being so selective, right? Like why some areas and not others.
Because it's not global warming, right?
No, it isn't the full globe. And even when they had to change it, they can't even call it, global warming anymore. They had to call it climate change.
Yeah, exactly.
But it's
Like
been
if you-
changing since this morning.
Yeah, if you use their own word and say, hey, it's global warming, then all of a sudden you're a science denier.
Oh, they don't say that anymore. That's right. Climate change. Is that what it is now?
Yeah, just climate change, or
Okay.
basically the word weather.
Humans are causing weather. Hmm.
I would imagine we have some effect. I mean, if you think about like New York City, all that pavement, how it would just absorb the heat. So you have this city heat, if you know what I'm trying to say.
Yeah. Oh yeah.
Increasing temperature as opposed to what nature would do.
I think that would be local, James, because if you really take a snapshot of the footprint of New York compared to all the rest of the state of New York, you know, if you did even a square meter calculation there,
Yeah, it would absolutely be.
I think
local,
that's a big part of it is just recognizing just how small of a percentage of the Earth we actually populate, let alone like affect.
Yeah.
I read this article, now that you mentioned that, I read this article that said if everybody on Earth was given 0.5 or a half an acre, everybody on Earth, it would only take up Australia.
No, it's less than that. It's, well, maybe, okay, half an acre. Okay, I got the one where it's every 7.5 billion people could have a 1,000 square foot house, and they would all fit within the state of Texas. Now, there'd be no roads in between them houses and shit. It would just be, but everyone could have a 1,000 square foot house and fit within Texas. That means all the other land, all of it, would be empty of people.
That's crazy, man.
We looked at a website that said something like that, and it kind of did a comparison. Can't remember what the name of the website was, but yeah, that stuff is true. You wouldn't be living very comfortably, though.
There's another one that says if Mount Everest blew up like it did before, it would take 10 years for man to put into the air what that one volcano eruption did.
Mount Everest, or are you talking about
Not Mount Everest, Mount St. Helens.
Mount St. Helens? Yeah.
The point of all those eco-warrior statements is to put you in a mindset that there's a kind of poverty of resources. The Texas statement does it all. Texas is tiny compared to the landmass. Distribute that and give like the equivalent of an acre or half an acre to everyone. There's plenty of land. Part of the rhetoric and the paradigm we're led in to believe the ball earth is that it's limited and that we're busting at the edges of what we've got. Look at Northern Asia and Europe.
How much easier will it be to convince people to dump money into a space project if you convince them that the Earth they're on is dying or somehow going to run out?
Yeah, poverty of resources, exactly.
Yeah, good point. It's more fear, controlled by fear. You got to keep everybody afraid of something. Yeah, that's a good point. That could support the space program. We got to go to Mars. We got to figure out how to colonize Mars because we're fucking up this planet. Think about that, though. Let me just make one point about that. Mars is this desolate, uninhabitable, nothing there. No trees, no fucking rivers, nothing. It's nothing like Earth. So we're fucking up our planet. We're going to go to this shithole that's essentially not even livable and set up there to live? What the hell sense does that make?
I think you can find, you'll find you can grow potatoes there, mate. So everything's good.
Listen,
okay.
Brandon, all we need to
Proven
do
by
is
Matt Damon.
we need to funnel all of our money into the space program so we can terraform it, okay? Stop asking questions.
But first you have to poop out space food, right? You know, because that's your fertilizer. So you have to poop out your space food, so then you can grow healthy potatoes on Mars.
Sounds wonderful.
What was it last
Brandon's right.
night?
It's the same thing, Brandon. They're appealing to poverty again. We need to go to this place because we can't sustain ourselves here. And your point exemplifies it. What? Go to a place with no water or air so that we can continue when we've got abundant resources that we're not. going back to the earlier point, there's abundant resources that we've not even close to tapping or even stretching. Yet the rhetoric we're given via city life is that we're busting at the seams. It's a falsehood to create a need for space and exploration. Yeah, let's go and mine an asteroid so we can get what? I don't know what's on that asteroid. You know what I mean? Let's go and mine asteroids. Let's go and grow potatoes on Mars. Nah.
Well, there
What's
could.
funny about
There's
what's
only
funny about the
5%.
whole thing.
5% of the oceans have been explored, right? I mean, there could be treasure chests full of Bitcoin down there. We don't know.
You know what's funny about that, Adam? What's funny about what you're saying, Adam, is even if they would, I know that they can't, but even if they went there, for them to like grow veggies or anything, what's the first thing they would have to build?
A dome.
I don't know. We should
Right?
we should definitely be exploring the bottoms of the oceans for treasure chests full of bitcoins, though. I mean, that sounds lucrative.
Just saying. You know, we've never been there. You never know, right?
Could be.
I'm just fucking with you.
But let's go to Mars instead.
I had this crazy thought that what they do is, all right, they set up these colonies. We're in one right now. We're in what used to be a colony. And then they say, there's this other place. And we're going to send people there. It's one of these things up in the sky. We're going to ship some people off there. And they're going to get it ready for us. And they ship people up there. And really, they're shipping people out past Antarctica into another one of these, you know, little puddles or whatever, or over to some other land that hasn't been used yet. They grow another colony, and they do the same thing. The people take the ship, they get in the ship, they go, they land in this strange place. They're like, "Wow, I'm on Mars." They have no fucking clue. There's a theory for you.
Almost like the Steve Torrance, that egg thing.
What's that?
Did you ever see that, Brandon?
I don't think so.
The black kid, he was, just say black, whatever, but younger, I think British, and he created the egg dome theory, which explained all the stars, all the movements, everything, and also the outer layers of this plane.
Martin Cheney.
Was it Steve Torrance or Martin? Yeah, maybe Martin.
Yeah, it was Martin
I've met
Kenny.
Martin Kenny. You can't describe him as a kid. He was older than me.
Yeah, but he
I
looks.
was thinking like a little 8-year-old or something.
My bad. No, my bad. He looks younger, actually.
Okay.
He's got a cheeky baby face, Martin, but no, he's like a 50-odd-year-old man. With you're talking about the guy that built a model and has kind of merged kind of Buddhist egg theory, Norse mythology.
Yeah. Yep.
Yeah, top bloke, Martin.
Really?
Yeah. He was on TV and shit, BBC Today or whatever the hell, stuff like that. Yeah.
Oh, I didn't know he went on those shows. That's interesting.
I don't know if he unified it in terms of any kind of proof. What he did was build a model, a bit like the guy in Close Encounters of the Third Kind in his kitchen, and brought it to the convention. That was a real good visualizer how things could work, how the wandering stars could operate on a separate system within the firmament, similar to that, and how a man could build that, give a demonstrable model that kind of works. Whether that was fully and encompassing, I wouldn't go that far, but it demonstrated that simple planar effects with rotating discs above a flat plane were perfectly capable of explaining what we see, and he links it, like I said, to Vedic and Nordic and all kind of ancient Egyptian even astronomy and astrology. So I don't think it was and I don't think he'd claim it was a full theory.
No, I thought it was a fun thing to think about, but I didn't see it as anything having to do with science or anything. You know, it's more of, hey, here's
It's
what
amazing.
it could be.
I was there, Brandon, when he unveiled it at the conference, and I remember you can go to the old Iron Rome footage back then. You'll see me. Do you see me just messing around, zooming in and out, or the there's all the modelling details that he's done on the plane, and it's not just got like the kind of the basic AZ map. It's more Kobayashi. So he's got outer rings, and those within Martin's model. Like I said, he incorporates stuff. Those outer rings have significance in terms of zodiacal effects, and golden, bronze, and silver ages. Those sort of things. So it's a really full description of his understanding. But I don't even think Martin would think he's presenting a theology.
Yeah, right. Yeah, you know, I like to think about those things, just like the theory that I just gave you. Who knows what the hell's really going on, you know?
That's kind of why I brought one up, was only because in that model, if I remember Adam Martin right, there were outer layers, you know, like you were just talking about, Brandon, which is totally possible. Who fucking knows?
Yeah, I mean, if we're on a flat plane, you would think that there would be somewhere else to go. It could continue. I don't know. Maybe it doesn't. I have no idea.
Martin's model has pairs going out. So you've got Mercury in the center, which is the new sun. Then you've got our sun and moon doing our sun and moon's thing. Then in the next ring, you've got Venus, which is the moon, for the next ring, and I think either Saturn and Jupiter, and then in the outer ring, Mars and either Saturn or Jupiter. I think I'll be corrected on that, but the construct is that basically there's ever evolving suns and moons, and the wandering planetas are old spent suns and moons, a bit like in Kronos and the likes, those being dead suns, dead gods. So it has that theology, and they still light and illuminate the outer segregated rings, if you understand it. What I'm saying from a Kobayashi point of view, from those outer realms. That's just what Martin was presenting as well. How there are pairs of planets. Does that make sense, Brandon?
Yeah, that was an interesting thought. Like, I got to thinking when he presented that, how would that even work? Because you'd have the sun going around a bigger circle, and then a bigger circle, I think, and it would, so the year would, or the day would be longer, I guess, unless it went faster. I don't know. I just started thinking about stuff like that, just the logistics of how that would even work as far as hot and cold areas.
Well, our sun in his model, as far as I remember, and Adam can correct me also, is it only exists in this realm, not on the outer, you know, or the third outer or fourth outer. And he also described our sun as a toroidal event, where it doesn't actually get further away from any pole or Capricorn. Like it goes up, spins, and comes down and spins. Kind of looks like an hourglass, I guess you could say. Spins like that, up and down, to create seasons. Right? It's kind of interesting.
Yeah, if anybody's interested in that, I did find a good old video that you can go check out. I'm by no means a proponent of this model or saying this is what Earth is. It's interesting to watch. He did put a lot of work into it, that's for sure. And I had heard some stuff recently. I don't know Martin, but I can't remember what it was. He was into something else. He thought he was Jesus born again, or was it something? You guys hear something like that? I don't know. It doesn't matter. Anyway, put the link in the chat.
Stephen Christ? You talking about Lord Stephen Christ?
I don't think so. No, it's all right. I can't remember. I did have a question for you guys, something that I've been thinking about, and that is whether or not light is affected by gravity or behaves like other things in respect to falling towards the surface of the earth. Not only in reality, but I'm also very confused about what it is that the heliocentric model is trying to say about light being impacted by gravity. Not that I'm so much concerned with that. Does anybody have a
I
good
dropped
understanding?
the torch once.
I can only see light being affected by mediums.
Well, before Rumpus jumps on, he's going to say, light protons have no mass, but they have momentum. Figure that one out. So here he comes.
Yeah.
Yeah, but we've all seen light being affected by mediums. Never once gravity.
Right.
have.
But does light fall to the earth? Is it
How does the
Yeah,
medium affect the how does the medium affect the light? It doesn't change speeds ever. It's always going the same speed.
Well, a straw in a glass, you'll see it affect the light.
Oh, like that you're talking about? Okay. No doubt.
Yeah.
Yeah, no, light is affected by the medium, Jeremy, right?
What's up?
Light's affected by the medium.
Yeah. I wasn't
It
sure
might
how he
be
meant. I thought
affected by
he was talking
the
about
medium,
speed.
but the speed.
Bro, I'm in
as
a
far
live
as I know,
YouTube
is
show
never
right now.
different.
What's up?
But does anybody understand the heliocentric model of light and how it's impacted by, say, I was reading something earlier today about the sun
Maybe not.
and its impact on light. And light goes by and it's bent into another direction or anything.
That's one of the proofs of general relativity.
Oh, is that right?
Yeah,
You know
what
about
was that?
There's
Einstein. Go
a
ahead.
this guy Edward Dowdy. He used to work for NASA, and he claims that that idea is debunked because it's really just like the density around the sun, that's affecting it, not the gravity. Because if it were the gravity, it would be bent the most closest to the surface of the sun, and actually you see the worst bending further out in the chromosphere.
Didn't Einstein predict the position of like Venus or something when it was behind the sun, but yet they saw it or some shit? And this they proves space-time gravity or some crap. Now the idea is though, Brandon, is like if light was affected by gravity, which they say it is, Rumpus will argue it all day long on your show. How does light leave the sun? That big old fucking thing with all this gravity that's attracting balls of rock around it and shit. How does light leave the sun then, right? If it's attracted by gravity.
Because it has an escape velocity.
Yeah, but you would think that the bigger, that's a great point, because you would think the bigger the mass, right? Light it only goes in one speed according to Einstein. So the bigger the mass, if gravity affects light, you should be able to distinguish those differences.
How do you distinguish the light that's going around the sun and the light that's coming from the sun? How do you distinguish those photons?
Hey,
I was
experiments.
making observations of like a star that, like, I think it's like during an eclipse, and they're making observations of a star or some object that's beyond the sun. And so
Yeah, you really wouldn't be able to, Adam. Good point. Because if you had a planet, orbiting this huge sun, but it was at far enough at a distance to where the sun's gravity kept the light from reaching it, you would never see the damn planet. So that's a good point. But that's how I would say you would have to do that. You'd be, maybe you flew to the planet, oh, this is closer, this one's far closer, so you get measurements and you see the bigger the sun, the less the light comes out away from it. But you're right, you wouldn't be able wouldn't be able to see the damn planet.
Black holes used to be objects so dense that not even light could escape, but now they've formed into these things that are jetting matter out of them, ejecting it.
Oh, they changed it. I didn't realize that. Yeah, so does anybody know this general relativity thing? Someone mentioned that that's how Einstein
Yeah,
supposedly...
Extremis was trying to talk, but then he went on deaf and mute now.
Oh, really? Bummer.
Yeah, he tried to get in a couple times, but well, maybe he'll come back.
Okay. Yeah, I'd love to hear more about this. If anybody out there is willing to tell us about this, that would be fantastic. Because I'm trying to
You
figure
talking
out.
general relativity?
No, I'm trying to figure out what it is they think is happening with light, and how it's supposed to be bent or whatever, and if gravity's affecting it. I hear this story about light is massless, which is fine, and whatever. But it's affected by gravity. It seems to be a lot of confusion out there from what I could tell on the internet. Just looking at different sites, looking at different experts.
They're very confused about light in many ways. They think there's some things they think they know. There's some things they know they don't know. It's a very mystical thing.
I guess so. So what is
The
this
double
thing?
slit got them all. The double slit got them all twisted up in a game.
Yeah, I think they were
That
confused
damn
before
thing
that.
got me twisted up. That was going as weird. It's got me twisted up.
Oh, having trouble hearing you, James. I don't know what's going on with your mic.
I got a little breeze coming in. Is that better?
Yeah, that's better.
I was just saying the double slit experiment. It's got me twisted up. That's a weird phenomenon because it requires the observer, obviously, but it's just all around weird.
Yeah, I don't know too much about that. Okay, well, I guess nobody really knows anything about it. We'll wait till Rumpus comes in, and then he'll
I
tell us
think
all
Jeremy
about it.
does.
That's a good place to say goodnight. Yeah, nobody knows anything about it. It's just observed what happens.
I got you. All right. Have a good night, Adam.
Guys.
Yeah,
I
good night,
finished the
Adam.
whiskey, so yeah, I've had a good one. And I just want to say, big day tomorrow for us English and Scottish people. So England v Scotland. It's not the Battle of Bannockburn, but it should be good fun. So come on, England.
What is it? How far in the tournament is it?
Oh, it's only a group decider, which will probably qualify anyway, but that's kind of irrelevant, mate. England versus Scotland, so this is bigger than ball versus flat earth for me.
Cool.
It's like a pride thing, right?
Well, considering my wife's Scottish and my in-laws are Scottish, if we were to lose, I don't want to live for the next.
Oh yeah, yeah.
So
every holiday you're gonna have to hear about it, right?
this is like USA versus Alaska. If you lot lost, you know.
Wasn't
Well,
there
we
a
didn't-
soccer like Puerto Rico, right? A U.S. team versus Puerto Rico team.
I think it'd be
Yeah,
more
you
like
lost to Puerto Rico. Yeah, Paulo One Chop scored against, I think, a famous game.
Well, good luck to England.
Yeah, thank you, guys. Irrelevant. Irrelevant. Yeah, have a good evening.
Yeah, see you later,
Brandon,
Adam.
one last thing.
Yeah.
Thing. I've got a couple of ideas based on the bee and the tunnel. Should I work with that and see what I can come up with for a
Yeah, that's fine.
the only I want chat room for the chat to come in. But you know the feed you've got in Discord in terms of the people in the chat. Do you want that appearing on screen, or do you want to keep all as reprobates hidden from the YouTube channel?
Yeah, I can pop it on there if we're just talking or something. It's just I can put it up and minimize other stuff if I need to. You don't have to specifically set aside room for it.
So within your main presentation screen.
Yeah.
And I'm being
Did you just say retrobates?
He called
Sorry?
you a retrobait, James. Yes.
That's awesome.
I
You just said
I
retrobates.
actually specifically
That's
included
great.
myself in that. You'll be, if you listen.
I take
I
no
was very,
offense
very
either.
careful to do so.
That's great. That's great.
Yeah. Cheers, Brandon. Right, I'll work on that. Give me a week or so, mate, and I should have a OBS and intro.
Yeah, no problem, man. All good. Thanks, Adam.
I'll do my best anyway. Right. Cheers, guys. Have a good evening.
Bye.
Bye.
Rachie put a note in the chat. They think the light is being bent by space-time, but it isn't affected by gravity because it doesn't have mass, even though gravity is space-time. Yet another contradiction. I was reading something else that they were saying, no. It's not being bent by mass. It's the acceleration that is bending the light. I'm like, what the hell are you talking about? How the hell would an acceleration bend? That doesn't even make any sense.
I think they screwed themselves when they said space time. They should have said something like space matter. But as soon as they brought that concept in, it doesn't really work.
Yeah, that's another thing we got to talk about that we haven't touched on yet. We talked about the time dilation. We got to talk more about length contraction. Because that seems pretty bonkers to me too. That the actual length of something is going to change depending on how fast it goes. So I'm not sure I completely understand the thinking behind that. But if anybody knows, maybe they can explain length contraction to us.
I don't know. Sometimes they'll say it's not actually shorter and it's just reference frame dependent. Sometimes they say it is shorter. I don't know.
I mean, do they still believe in all this stuff, or is this like old stuff? Did you guys give up on Einstein, or are you guys still sticking with Einstein, or what's going on?
It's the best explanation so far. We're open to better explanations, but we don't have one yet.
So still Einstein
Get
is
hot,
the guy, huh?
shit. We're hanging out here
One of
for.
many. One of many.
Get working, dude. Keep coming here like thinking you're gonna prove something.
Don't these I was thinking about this. If you come up with a theory, I've said this a couple times, and the end result of it is, you have to believe in time travel and then this length contraction. Don't these things contradict all of our other experiences of reality? Nowhere can we show anybody going forward or backward in time, speeding time up or slowing time down or stopping time, whatever you want to call it.
Well, we have speeding up and slowing down. We have that, but backwards, you're right. I don't think we have any evidence for that.
Yeah, I don't think we have it speeding up or stopping either. And then the physical length of something changing based on what? Its speed? Do we have any examples of that happening? These things seem to contradict reality to me. So if I were told an explanation,
my bad. Isn't that how they say an interferometer works? Or what was the guy they always quote for the ether?
Michelson, I don't know.
Yeah, Michelson Morley or something. The thing they were doing wasn't. Then they. That's what's happening at LIGO. No, is length contraction. The pipe's getting shorter by 1/10,000th of a proton or photon.
Oh, is that what they say?
LIGO, it has
the Michelson Morley. I thought was more Earth rotation.
Tell me LIGO's not doing length the Lorentz contraction when they check for those gravity waves. I'm pretty sure that's what it biodual. Do you not know, or
No, I don't know. I don't know much about LIGO. I know the physical structure, but the exact experiments they're doing, I know that they're messing around with gravitons and shit like that. But I could not for the life of me explain how or why they're doing it.
I thought
But yeah,
relativity had been
I
undone
thought it was
because
just
you're getting
triangulation.
spooky action at a distance with quantum entanglement. That's my understanding. That relativity is like the old busted.
Are
I
you
thought
saying
their
that
initial,
you're saying they have
foundation-
given up on it? Then who was that? Farming Ganja?
Yeah, that's my understanding. That when it comes, because quantum mechanics, is depending on this quantum tunneling and things that happening faster than the speed of light.
Oh, okay. So you guys don't even have to defend this stuff anymore, Balduel. You got
No,
new
so
shit already.
there's a very specific point that needs to be made, and I'm sure Farming should probably agree, is that at the quantum level, you probably could throw out Einsteinian relativity. You probably could, and you probably should. There's probably a better explanation. But when we talk about the really big, and then even at our level generally, it's still the best explanation at the moment. Until we have a unified theory that works everywhere, then yeah, we're going to have places where it doesn't work.
Let me read this for the audience just so they understand what length contraction is. Length contraction is the phenomenon that a moving object's length is measured to be shorter than its proper length. I'm assuming proper length equals its actual physical length in reality, which is the length as measured in the object's own rest frame. Yeah, okay. It is also known as Lorentz contraction and is usually only noticeable at a substantial fraction of the speed of light. It only happens in the direction the object is traveling. So I guess if you...
Wasn't the Lorentz? Did you say Lorentz? Sorry, Brandon.
Oh, it's all right.
Also known as Lorentz. Is that what you said?
Yeah, Lorentz contraction or Lorentz Fitzgerald contraction.
So that
what?
I want to say the project by the military was Loran, Lorane, where they just did triangulation, and LIGO was in other words, the foundation of LIGO was the Loran project because they didn't just throw all maps away and start over.
No,
they already had
the two are not connected.
Not at all, huh?
No,
just
Lorentz,
acronyms.
No. My bad.
They sound similar, but Loran and Lorentz. Loran is an acronym. Yeah, Lorentz is, I think, someone's last name. Henrik Lorentz. The guy who evidently had something to do with saying that objects get shorter as they get faster. That's what it says, right? They get shorter. Yeah, they get shorter. So if I move faster, I get shorter, and I go into the future. Correct? I speed up time, and I get shorter. Actually, it'd be skinnier if I'm moving forward.
That's what I was going to ask. Is it width and height, or is it just one?
It happens in the direction you're traveling. So I assume that it happens along the axis that is
right,
perpendicular to the direction of travel. Is that right?
I don't know.
Something like that. Anyway.
That's what I'm picturing in my mind.
Yeah. So this is
picture that, though.
You can. Okay, that's interesting. So that's what makes me wonder.
Like a baseball, like throwing a baseball.
Yeah.
But it does. But how do they distinguish that? Because of course it's going to look smaller as it goes away from you.
Yeah, I think these guys are saying it actually, in reality, actually physically gets shorter.
Wow.
And it physically speeds time up. Like, this isn't just how it looks. Doesn't look shorter, because I know what you're talking about. It actually...
Well, they do claim, like, on an airplane in the so-called satellites that they have to constantly adjust the time. Don't know myself if that's true or not.
They
is
say
a
that
claim.
over and over. Yeah, that's their big. That's their main support. It seems for this that they always bring up is we put a clock on a plane and we had a clock on the ground, and it was some ridiculously small fraction of a second different when we checked them again after the plane landed. Pretty much some variation of that, and they're saying the same thing is happening with GPS satellites. So GPS satellites are whizzing around, time traveling into the future, and they have to make adjustments because they need to be able to talk to each other. So they have to calculate distances and whatnot differently to account for the other satellites going in the future at a different rate. I don't know. It's all very, very confusing. But my question is, if I say had a rocket ship and I packed the rocket ship up and I went so fast, let's say that this 100-foot rocket ship squished down to the size of, I don't know, 10 feet. Would I get squished? Would my body become jelly? Would it like squish me into jelly or what? How does this work?
I'd like to say something about this. Hello?
Okay.
You would have to, but go ahead, sir.
Yeah, as far as I understand, that you wouldn't notice any change in your time or the length of yourself or your ship, but you will see like the planets around you are being squashed, because for you they appear to be at a very high speed, close to the speed of light.
Right. How do you know this?
No, I'm just explaining what I understand. I'm not saying that this is true or no one. I mean, at some point, maybe science. This is the prediction of science. Maybe at some point, when we reach such speeds, we discover that these laws bend somehow at certain point.
I mean, is it all a guess, or are we doing it now? Have we ever? Don't some things work off of this Lorentz contraction principle, or no? The Michelson-Morley thing had nothing to do with it.
I did ask for any. Is there any experiment about length contraction, and the only response was the LIGO, but the LIGO contraction is because of that gravitational waves, not speed.
Yeah, but Brandon's question was, or he's saying that you actually physically get shorter. So if that's the case, then yes, you would get squished. It would have to mess with your skeletal, your ligaments connecting to your skeletal. It would mess with all that. If you're physically getting shorter, and it's not just an appearance, you're actually physically, then yeah, it's going to squish you.
No, I don't think so, because when I get confused about these paradoxes and theories, I try to get back to the basics, which says that any experiment you would perform, it should give the same results, no matter what your speed is. So for me, if I have a measurement of 1 meter, it will always be 1 meter, whatever my speed is. My perception of the world that is not moving is that is going to be squashed. So the world is going to see me squashed, and I will see the world being squashed. So I think it's not a physical thing.
No, that's not what they're saying. The Crow. That's not what they're saying. James is right. They are saying that it's physically getting shorter.
Yeah. Well, let me tell you. I talk to many people who are more knowledgeable than me in this. And they had confusing point of views.
Really?
Like one of them tell me physically, and the other says no, it's just perception.
That's the same thing we heard when it came to the time dilation too. There was different points of view on people who seemed to think they knew what they were talking about.
Brandon, real quick, load up.
Again, it says
Hold on a second.
appears to or is measured differently.
Hey, real quick, Brandon, Google Lorentz contraction and LIGO together, and a whole bunch of stuff will pop up.
Okay. Parmesan, what were you saying?
See, I was thinking they had to do with one another. Sorry, go ahead.
Parmesan, you said something. Sorry, I missed it when you said it.
Yeah, but if they have opposing views on whether it's physical or an appearance, then that tells me there's no actual experiment to confirm one or the either. Both of them are void. Just my opinion. If that's the case, where there's opposing views.
You know what I think? I think the people who say that it's not physical and it's just visual are doing so because it doesn't make sense to them. So they think that it makes more sense if you say it just looks like that. But that's not what these theories are saying. These theories are saying that time is really speeding up or slowing down, and the length of objects are physically reducing the faster you go.
Yeah, but time is just a man-made concept. In other words, we can make 2 minutes 1 minute. It's just it's 120 seconds. That's,
well,
1
just
minute.
The measure. Yeah, I get what you're saying.
See what I mean? It's like I don't know.
No, but they made time. I don't know if physical is the right word, but they yeah, I don't know how to describe that, but they made it a dimension of reality, I guess might be a good description. Just like length, width, height, and time, distance, time. Oh.
Yeah, our time is man-made time is based off nothing but the sun, moon, and stars. Probably just the sun and moon.
That's just the cycle, yeah, and we tie it to the rotation of the sun and other things, yeah.
Man.
You know,
That
I've
part
been
of it's
thinking
man-made,
about
but time. But we get into this argument because people say, "Well, time's not real." Yes, you're right. We've defined what time means as far as what units we're going to use, what the different durations are. Those are all man-made concepts. But you know, no one would say that time isn't passing, right? Time isn't. We aren't experiencing some sequence of events that is predictable.
Yeah, well, good point. I would say that without man on the earth, and yet you had everything else, yeah, the animals are still going to experience night and day. They're still going to have that time frame, whether they, have a watch or not. They know when it's time to hunker down or whatnot. So it's a good point. If that's what he was trying to say, there's still time without man. It's just you can calculate it in so many ways. It's just a concept. There's no way you could travel through it. It's set. It is set. The time is set. It's off the sun and moon, so it's set. There's no changing it. You can calculate it many different ways, but there's no changing what has been set.
Well, we certainly can't change the path of the sun, at least that I'm aware of. But yeah, I'm not finding anything about LIGO and Lorentz contraction. It seems like a lot of articles saying, should it have been impacted by Lorentz contraction? And I'd have to read through it to make any sense of it. But
I think Lorentz contraction is about speed, but LIGO is about gravitational waves. I'm not sure if they are the same or like come from the same mathematics, but that's what I know or understand.
Yeah, I don't know how the two are tied together.
Either one has to mention the Loran project at some point. At least I don't know that for sure. I'm just thinking that in my head because the United States military with the Loran project triangulated at least the United States and created the most accurate map of that time. So I don't see how LIGO or Lorentz, it's almost like that would have to be their foundation, their base, the Laurent project.
Yeah, I don't know how the two are connected, to be honest, outside of Loran having a connection to GPS, but I'm not understanding the connection. Anyway. So do you buy into this stuff, Crow? This Einsteinian time dilation and length contraction stuff?
Length contraction, as I said, I looked for any proof, nothing that satisfy my curiosity or suspicious. But for time dilation, I think I told that story before. There's a particle that's generated at the upper part of the atmosphere, and it hit the ground, and its lifetime is shorter than what we expect or what we
Very
calculate.
nice. Thank you.
It's called the muon, or MOUN. So it takes, let's say, its life is 1 second before it decays, and the trip, since it generates before reaching us, is 2 seconds. So how do we receive it? So that's what made me convinced, really. Nothing more. I heard a lot of shit that didn't convince me, but this is the one that convinced me.
What's this, Jeremy? LIGO experiments cannot detect gravitational waves by using laser Michelson interferometers. Light's wavelength and speed change simultaneously when gravitational waves exist, which make the detection of gravitational waves impossible for LIGO experiments. Whoa, what is this, Jeremy? 2016 Journal of Modern Physics. This is a peer-reviewed article about how LIGO can't detect gravitational waves after they announced that they had detected gravitational waves.
I thought there was a Lorentz contraction connection there with LIGO. I wasn't even interested in that part. I mean, that's, yeah.
You know what Lorentz contraction is, Jeremy?
They've been talking about it for a while, Brenda.
What it is?
We just read the definition, Brenda.
Yeah. Do you know what it is?
Yeah.
Go ahead, Brenda. Yes.
Yeah, do you? What is it, Brenda? Hello?
Why is there silence?
You just witnessed a Lorentz contraction right there.
In a time dilation.
Did she lose connection? Is she still in here?
I think she's having some audio issues or something.
Yeah, I'm here. I'm just wondering if you know.
Yeah, do you? Yes,
do you know?
know.
Go
Do
ahead
you?
and tell us.
Yeah.
Yeah, that's the answer to my question.
Yeah, I did answer your question. I said
I
yes. I
don't have a clue.
There you go.
Sorry,
James
Brandon.
doesn't know. Tell James what it is. Brenda? Hello?
I'm having supper, so I'm pausing.
Oh,
Well, you're the one coming in asking questions. Why don't you go ahead and eat your supper and then come back?
It's so important to stop and ask us questions and start a conversation.
No, I don't think you know.
I just told you we read the definition. We just read about it.
Okay.
All right.
That's probably why you came in, Brenda, asking about it, because you knew we was talking about it.
Yeah, well, what we're more interested to know from Brenda, I think she can help us with, is it physical contraction or appears to be contraction for a different observer?
There's no difference.
Yeah, there is. There certainly is a difference. Are you telling me that there's no difference between the way something appears and its physical reality? Is that what you're trying to tell me, Brenda? Oh, fuck this. I'm not gonna fucking play second fiddle to her
All right.
fork.
That's ridiculous. You're doing it on purpose too.
Let me give you some thought experiment about time dilation. It's funny. So let's say I'm bodybuilder and there's a rival, a competitor, and he's a little bit bigger than me, and I do say 100 push-ups every day, and the contest is maybe 7 days from now. So I go in a ship close to the speed of light. I'll do maybe 2,000 push-up because I experience time to be 20 days instead of 7 days, and I come back to Earth and I win the contest.
No, you wouldn't win. Not against a bodybuilder. If you're doing push-ups,
well, not
you're
me.
burning. Hold on. If you're doing push-ups, and I get
Just a
your
hypothetical,
point.
bro.
Don't get me wrong, I get your point. But if you're doing push-ups, you're gonna burn more body fat than you are gonna turn body fat into muscle.
Bro, this isn't bro.
Yeah, he's totally ignoring what the point was. Yeah.
No, I get his point. I admitted it.
But he got my point. But this is good information. I'd like to hear it more clearly.
See, why'd you guys try to stop James from continuing? He was helping Crow out. Crow was appreciative, and you guys had to jump in there. What the fuck?
What, when you laughed?
Well, I found something funny.
Yeah.
I'm sorry. What am I supposed to do?
So if you go down and do push-ups against a bodybuilder, and all you do is push-ups, and he lifts weights, you're gonna do far more.
The point was, I know. The point was he'll have
You'll look
20
like
extra days. The point was he'll have more days.
Have you ever seen the Olympic ring guys? That'll be more of what your build looks like. You wouldn't turn into Arnold Schwarzenegger.
The point was he'll have more days to get ready for the competition. You know what I mean? Let's say it's a chess competition.
The other way around, the guy on Earth would have more days. Because isn't it time dilation for the guy that's going closer to the speed of light on the ship?
Yeah, his time's going faster. I think you did get it mixed up, Crow.
You would actually miss the competition because 20 days would have passed. But it would have been like 5. Yeah, it is the other way around.
Yes, you're right. You're
going to need the reverse time travel for that one. Hold on, Brandon. Tell him how to do the reverse one.
See, to go back in time, you have to go faster than the speed of light.
No, so I will not go to space. I will send my rival to the space.
You got to go. All you got to do is go faster. That's all. Faster.
Or go backward.
And you go. That's reverse time travel. Yeah, that's when you go back, Michael J. Fox style.
There you go. Spend like 10 years doing James' regiment, his upper body regiment. Do a bunch of push-ups. Get in the old spaceship. Go faster than the speed of light. Show back up at the competition. Bam, smoke them.
I do have a question.
Yeah.
Who would win in a fight between Mighty Mouse and Superman?
Superman.
That's a tough one.
That's the correct answer. There's no way a cartoon
Mighty Mouse has to have kryptonite. That's the only way his chance. That's the only chance Mighty Mouse would have, is if he had kryptonite.
There's no way a cartoon could beat up a real guy.
Well, Superman's a cartoon, dude. The origin of Superman was a cartoon, not a movie.
Yeah,
that's a real guy.
The movie's based off the cartoon.
Yeah, I saw him go into space and stuff. So what are you talking about?
He reversed time too. Yeah.
Yeah, there's a photograph of Superman in space with a curve.
Did you know that was based on the work of Einstein? He got a credit. If you watch the credits on Superman 1, said based on the idea by Einstein.
Did it say Albert? Albert Einstein?
It said A. Einstein.
Right. That's usually how they do it.
Yep. Anyway, now that we've got that important stuff out of the way, who was it we were asking? Oh yeah, Brenda, are you done eating yet?
It was Brenda.
Why? What?
We were looking for clarification on whether it physically gets shorter or it just appears to get shorter. You said
It's
both.
it's a real shortening, just like time dilation is a real stretching of time.
That's not the way that I understand Lorentz contraction. I understand Lorentz contraction as an observer outside of this object would see it appear smaller, but if you were on this object, you would not be smaller. That's the way that I understand Lorentz contraction.
That's how I would take it.
Well, let me read the
If you're
definition one more time because
smaller,
it's very specific, and I think the wording, it is Wikipedia, albeit, but you'd think it would have been corrected by now if it's wrong, right? Length contraction is the phenomena that a moving object's length is measured. I don't know what that means. To be shorter than its proper length, which is the length as measured in the object's own rest frame.
It sounds like they did it already because they're saying it's measured. They must have measured it.
No,
Yeah,
that's just the principle of it. I can't find a true experiment for it. That
the first time I thought you said
go ahead, James.
reference
You got
frame.
this.
No, I'm sorry, man. Brandon, the first time it sounded like you said reference frame. This time it sounded like you said rest.
Yeah, rest frame.
R-E-S-T, rest.
Yep.
If that's the case, then it's saying physical.
That's the proper length. So if it's not moving at all, that'll be the quote unquote proper length. When it's moving fast and approaching speed of light, that'll be the what they call the measured length. And they're saying that these two lengths would differ.
But Brandon also made a good point because he said measured, whatever that means, which is a good point because how do you measure something moving extremely fast?
Here, so what I'm reading here kind of goes into it a little bit more detail. In this last sentence of this paragraph, close to the speed of light, distances measured are not the same when measured by different observers. So that's why my understanding is, depending on the observer, it won't be the same. It'll be different.
So are they using a camera and counting the pixels to measure it?
Right. That's why I just said I think this is just the explanation of the theory. I don't know if there is an experiment showing measurements.
Right.
I'm trying to find the experiment. So I think it's just an explanation using an understanding of physics. But I don't know about experiments.
Huh. Well, that didn't
Yeah,
really...
we fucking know you don't know about experiments.
Great job,
Remember when
Jeremy.
you tried to give me that? Remember when you tried to give me that astronomy theory or whatever you were doing?
Yep, there we go. Astronomy theory. Yep, that really narrows it down, Jeremy.
Well, I mean, it's in a numpty clip, so.
Yeah, when we were explaining that time can be an independent variable, and then you cried forever, and then I gave one example, and you said, okay, right there it could be an independent variable. So we made progress, but you probably forgot about that, so maybe the progress didn't stick.
No, you didn't make any progress. All you had was that time. Something happens in time. You had nothing. That's all you had.
Yep, we talked for an hour, and that's all I said. You're right. You're right, Jeremy. You got it.
In the end, that's all you had was with your experiment or your theory or whatever. You're like, yo, a light moves in the sky over time. Fucking brilliant. That's profound.
Yep, we talked for an hour, and that's all I said. You're right.
And told her this profound news.
Oh my fucking god! Is Jamie still on his time can't be an independent variable bullshit kick?
Who? Who's Jamie?
Jeremy.
Oh, Jeremy.
All the flat earthers feel that way.
Yeah, that's why manned space flight stops, is because you need the 1960s time frame. Otherwise, no space flight. Time causes space flight.
Oh, gotcha. Yeah.
So the idea is that the way we measure things, that's just what it means for something to be real. So if I measure a 2x4 and it's 6 feet long, that's just what it means for the 2x4 to be 6 foot long. That it measures to be 6 foot long.
The hell does that mean, Brenda?
If it's moving at 200 miles, we'll just say 200. If it's moving at 200 mile an hour, how do you measure it, Brenda, physically?
No, did you hear what she said though, James? What the fuck did that mean, Brenda?
It means that when you measure something, that's what it means for it to be that long.
What?
no what there is there's no absolute reference frame for length, right?
What about
so
the
things
object
just are
itself?
there isn't an object itself. It is whatever you measure it to be.
Oh wow, this is getting to be some fucking hocus pocus shit here.
Well, you mean
So
you think there's some absolute length or something?
yeah. If I have a 2x4 that's 6 feet long, no matter what I do with it, as long as I don't break it or bend it, it's gonna be fucking 6 feet long.
Yeah, but that's
No matter how
arbitrary.
fast I accelerate it.
If you accelerate it, it will you will measure it shorter to your reference frame, and to somebody who's standing on the 2x4, they will measure it as being 6 feet long.
Physically or apparently?
Yes. It's measurement is just how we know something is real. That's just what it means to be real, is that it measures.
Oh, like Earth curve. Since we can't measure it,
Brenda.
we can't know that it's real. Hold on. Yeah,
we do measure.
I
Earth curve all
understand
the
that
time.
totally, Brenda.
I measured Earth curve just during the equinox. You could have done it too, but you
No,
chose
you
not
didn't.
to.
Yeah, Brenda, we were speaking on opposite sides of the same coin. I understand what you're saying. Because it's still reference based. It's still reference based, but you're making the distinction that if you measure it, it is a physical measurement, and that's where I was being disconnected from.
So if I have a 2x4 in a rocket ship and it's going, half the speed of light past me, if I were to measure that 2x4 as it's going past somehow, it's going to be shorter than if I'm in the rocket ship and I measure the 2x4. Is that what you're telling me?
Essentially, yeah.
How the fuck is that possible?
Due to the Lorentz contraction.
No, funky.
It's a contradiction.
It's
contradiction.
the funky things happening at high speeds.
No, it's not happening.
Right.
That doesn't happen.
Well, here's
Nope.
a one-to-one analogy. Hold on. I don't think they have.
It's a contradiction. Violates the law of non-contradiction. It's a contradiction.
No. So here's a good analogy. No, stop. There's a good analogy, and it's the same thing with speed. When you're on a moving vehicle, your speed in reference to that vehicle is 0. When you're off that vehicle, going the same speed, your reference to that vehicle is some type of value. So it does depend on your reference on what you're going to measure. So you recognize that with speed, it'll be the same thing with length, essentially.
No, because if I'm in the car is going to be just as long as if I'm standing outside the car.
At car speeds, yes.
So one thing is I kind of enjoy putting relativity concepts in such a way that flat earthers' heads explode. I kind of enjoy that.
Yeah, it's because we try to apply logic and reason to the nonsense, and you'd like to see people struggle with maintaining their grip on reality.
That's why
Brenda, you just admitted that it's an appearance and not physical.
No, it's physical.
Yeah, I just like phrasing.
explain.
I just like phrasing it in such a way that it confuses you. I just kind of. It's
I'm not
kind of
confused.
No, it didn't confuse
No one's
me at
confused.
all. What you said is if you're in the rocket with the 2x4, it still measures 6 feet. But if you're outside, it doesn't, right? So that's an appearance.
Nope,
It just
physical.
appears shorter.
No,
No,
Well,
because-
okay, if you're out,
because
hold
you're
on.
measuring
If you're outside of the rocket ship, how did you measure the 2x4?
Because if you're standing on the 2x4, your measuring sticks have contracted along with it.
Yes, I agree with that. So it's an appearance. If you're off the 2x4,
physical.
how do you, hold on. If you're off the 2x4, because when you're on it, I can picture you being able to.
You can't measure anything if
Let
you're
me finish. I'm almost
if you're not
done.
physically
If
touching
you're
it, you
on
can't
it,
measure
I
it.
can picture you taking out a tape measure and physically measuring it. But if you're not on it, right, and it's whipping by you, how did you measure it? What was your tool? What was your physical measurement?
Such an idiot.
Did you just eyeball it and it seemed to be shorter because it appeared that way?
Here's
What
an
was your
idea.
physical measurement?
No, James, what they're saying is, if you have a tape measure and you have a 2x4,
Oh, you
and you're
already
on the
know
ship,
the length of it.
Yeah, no,
I think actually,
the measuring tape is also going to contract.
yeah, that's why at that
wow.
point, eyeballing would be the best solution. So you took a
No,
square,
if
or
you,
your hold on, your spaceship. Let's say there's squares of tiles. The tiles in the spaceship is squares. So when the spaceship go like 99.99 of the speed of light, are they going to remain squares for you? Are you going to see them squares, or are they going to be
Yes.
rectangles?
If you're on the object on those tiles, yes, they'll still appear to be squares, and then they'll appear to be
I believe
rectangles
so.
to an observer on the outside.
And they will still be squares in reality, physically.
Well, it depends on your reference frame, because your reality outside of that object, your reality outside of that reference frame says that those are rectangles. Your reality on that object says that they are squares.
No. See, if I'm looking at just because something looks a certain way doesn't mean it physically is that way.
Here's
it
the way.
measures that way.
Yeah, it measures that way. So here's a way to think
Not
about
reality,
until you
though.
land on it. Until you land on it and get its true.
Sure, you change your reference frame. Sure.
Yeah, but you're saying that your reference frame is true. What you're seeing is true.
Both reference frames are true. Both reference frames in this example are true, even though
you're saying the reference
Go ahead,
frame
James, you're
that
going to get
you're
to the end
in.
anyway, so go ahead.
You're saying that the reference frame you're in is giving you an appearance.
Nope, it's physical.
That they're triangles.
It's physical.
You can measure.
I can help you guys.
How could it be physical? How could it be physical if when you land on it?
I can help
change your reference frame, you moron.
I can help you out,
Right.
James. James, I can help you out with this.
I can kind of picture that. I see what you're saying. You're just changing back and forth from reference frames.
Exactly.
That's all it is.
That's your measurement.
Right.
But isn't one of them true and one of them false? Or no?
True.
Well, think about it this way. The speed measurement. So if you're on a train, your speed in reference to that train, let's say the train's moving 100 miles an hour. That's what we measure in the cockpit. Whatever. You're on the train. Your speed in reference to that train is 0. That is true for you. That is reality. In reference to that train, your speed is measured to be 0. Now, if you change your reference frame, that train is still moving on the same tracks and you measure at the same point, but now you're on the ground and the train is going by. You measure it to be 100 miles per hour. So in what you think is one reality, what is the speed?
In both
depends on your
realities, the
reference.
speed of the train is 100 miles per hour.
No, because you're only referencing an observer to the train. You're not at all referencing the train to the ground.
You just want to figure out, then what you're talking
train.
about, BioDual, is the differential between the observer's speed and the train. That's not, doesn't mean the train's not going 100 miles an hour. The train's still going 100 miles an hour.
How do you tell? How do you tell you're going 100 miles an hour?
Same with the length. It's the same with the length. It's only in reference to each observer measuring the length. That's all.
I have a way
So
of.
shouldn't there be a difference? Hold on. Shouldn't there be a difference if you was in 2 reference frames, such as instead of inside the train, you're on top of the train? Well,
Sure.
you're in.
I mean, that's a different reference frame, but if you're still on it and you're still moving with it,
you got wind.
Yeah,
you got
still,
wind.
It's still that differential of 0.
Let's say you're on a high-speed train that goes 120 mile an hour, right? You're going to see a huge difference when you're inside the train, and then you're up on top of the train.
I can.
When you're on top of the train, you're in 2 different reference frames, right? Shouldn't there be a difference of measurement of the train?
No.
I can help you out with this. Suppose I have a train. I have a train that's 1,000 feet long, and I have a tunnel. The tunnel has doors on each end, and the tunnel is only 800 feet long. The train is traveling at a significant percent of the speed of light, such that it can fit entirely inside of the tunnel.
Yeah, it's not possible.
Yeah,
it is. It is possible.
Things don't contract in length depending on how fast they're going.
They do.
They don't.
Actually, they do.
No, they
Been
don't.
measured.
Just to an observer outside of it. But again, I'm still trying to find experiments. But this doesn't break any known laws of physics. I think that's the underlying point, is that this explanation doesn't contradict anything that we know in physics, and it actually follows a few principles. But again, I'm trying to find experiments.
No. You're describing it in such a wish-washy way.
No,
in my
your
opinion.
inability to understand isn't a fault.
No,
of
it's
the,
not my inability to understand. It's your inability to understand. If
No,
you have a
you're-
2x4
I know we
that's
can go
6
back and
feet
forth.
long,
We can go back and forth and then negate each other, and a scientific theory stands until you prove otherwise. So we can
I
go
don't
back and
care.
forth and
You
insult
can
and say we
write
don't
this shit
understand.
down in any
but
book you
this
want
stands.
and tell
still
everybody in
stands.
the world that this is gospel and this is the truth. Who gives a shit? This is nonsense.
It's been proven. It's been
No, it
proven.
hasn't.
Well,
Yes, it is.
hold on, because I would agree that there's such thing as a scientific theory. In other words, hasn't been
If you know what a
proven
scientific theory is, you wouldn't just say that.
And in other words, it hasn't been proven yet. It's just the best
That's not what a scientific theory
explanation.
is.
Really?
That's
It's
not
an
what-
it's an
that's not what
explanation
scientific
supported by
finish,
evidence.
dude. Let me finish and then.
No, I hate when people say it's only a scientific theory, therefore it's not proven. It just shows
All
you
right,
have
all
no
right,
freaking
all right.
clue what
You
a
just
scientific
hold
theory is.
Hold on a second.
Sorry,
You
pet
just
peeve
said
of mine. I'll shut up now.
you just said it's the best theory of the time. If you want to, if you think you can do better, then let me hear it. You said, I'm paraphrasing, but you said something along those lines.
Yeah, I said that. I said that. Yeah.
Yeah, it's true.
So in other words, you admitted that the theory of the time could actually be wrong, not true. It's just it takes time to get the better one. Right?
I can
said.
clarify. I can clarify.
How did I say before you interrupted? How
No,
was I
can
saying?
clarify. Well, I think what it was is that you were insinuating that there's no evidence or supporting validation for that theory. Scientific theory is essentially an explanation for something that is. Come on, James, man. Come on. We let you go all the way. We let you go all the way. Give me just a few seconds, man. So scientific theory is essentially an explanation for something that is supported by evidence, that is validated in some way. Perhaps not all the time, but there are evidences to support it. Now, when it comes to things in physics that aren't unified, you will have scientific theories in which they work in some places, where they don't work in others. But that where they work, there is no better explanation at the moment. So yes, when we talk about like gravity, for instance, I don't think you could say that one day it will be wrong. I think it's not complete. So I think there's more information and more factors, more variables that will be added to the theory, but I don't think that there will be something that contradicts the theory. But I mean, if there is, I mean, fuck it. Yeah, sure.
You don't know.
So that's what I'm saying.
Of course I don't know, but it is the best one we have today at the moment.
Let me rebuttal. I'll try to be real quick and then I'll mute. So a scientific theory is not proven. A scientific fact is.
No, stop it. No.
Such as, hold on.
No, a fact is observable. You're messing up completely. You have no idea what the hell you're talking about. No, I'm not going to let you finish when you start off with bullshit.
Yeah, you are a paid NASA show. Let him finish, and then you can respond.
Yeah.
Go ahead.
So if I take a knife to my skin, I apply a certain amount of pressure, and I slice it. I move it one direction or the other. Every single time I'll bleed. It'll never change. It's a fact. Right? That's not a theory. That's a scientific observation, experimentation, fact, truth.
Theory does not mean
a theory can be like you was saying. The best explanation of what's going on at that time. But it can still be let me say this, superseded. Meaning what was once thought to be, I'll cut you with the knife, you'll bleed every time. I guess I can't say that because you get what I'm saying.
Yeah.
I'm agreeing with what you're saying.
To a certain extent, I don't completely disagree with you. I don't completely. It's hard to put a definitive statement like gravity will never be superseded or deemed to be 100% wrong. I would never say that. We can only make predictions in which it could be made better, it could be edited, whatever the case. But to a certain extent, you're right, in which a scientific theory at some point could be wrong, but it can also be improved. It can also be the degree of accuracy of this theory could be improved. All these things could happen, but just because a scientific theory may not stand up to scrutinization in 100 years doesn't mean it was wrong. It could just be incomplete.
I would agree, but if you're just going to keep adding theory and theory to support the first theory, Not one of them are a
You
fact,
don't understand what
right?
the word, the
You're
word
just
theory.
adding theories to make it seem stronger.
Well, scientific theories are backed by evidence and validation, though. That's the thing.
You're
Speaking
using
of
theory
evidence
in
and
the general
validation,
sense.
when was this length contraction observed?
I don't know if this is a scientific theory. I think it's a principle within physics, but I don't think it's a what we would deem the title scientific theory.
Because it calls it a phenomena here, is the phenomena. So that makes it sound like this has been observed, this length contraction.
No,
Has it?
I think they're just explaining. I think they're explaining using other principles and other scientific theories within physics. I think they're explaining something that we would expect to happen based on those, and because there's no contradiction, and because it follows the confirmed scientific theories and stuff like that, I think they have no problem with it.
There is a contradiction though. The contradiction is that physical objects don't change their size.
They do when they go really, really fast.
No, they
And
don't.
it depends on the
Got
observer.
nothing-
So
Show me the evidence.
If
Right.
it was validated, it wouldn't be a theory anymore, isn't it?
No, it's not. That's not what theory is. You guys are misusing the word theory.
You gotta go read what theory means.
No, you need to read what the word theory is.
I know
It doesn't
what
mean what
theory
you think.
means.
No, it
It's
does
not
not mean
real.
what you think it does. The
Theory
scientific
is
theory
not-
does not mean something to be proven. It does not mean that it's a wild guess. Oh, it's just a theory. That's bullshit.
Yeah, that's what it means.
No, that is
no,
not.
not a scientific theory. There's a layman theory. Like I theorize if
Yeah, it's just a
put a
wild-ass
pillow
guess.
if I put a pillow in my room, my dog might be interested or whatever. It's just a theory backed by nothing, whatever. It's just my
Yeah,
layman
you
theory.
put in
But a
the
scientific
word
theory.
scientific
But a
in
scientific
front of
theory.
theory,
But a
it doesn't mean
scientific
anything.
theory. Scientific theory is substantiated by
By what?
previous experiments and evidences.
What experiments?
I mean, how pedantic do you want to get? Because you're
I think
I'm
the
only,
word
I'm
you're
only
looking for
explaining
Down
theory
to
and
what
scientific.
as much
Hold on,
as we
guys.
can,
Don't
right?
talk over each other. Go ahead.
I'm only explaining the difference between a layman theory and a scientific theory. That's all I'm doing.
So one observation that confirms it would be cosmic rays.
Tell us about the cosmic rays, Brenda.
They only last for a very short period of time, and yet they travel from the top of the atmosphere all the way to the surface of the Earth. That shows time dilation.
When did someone within the reference frame of the cosmic ray measure it?
You can measure that in the lab, right? So we know that the cosmic rays, that in lab conditions, they only last for a very, very, very short period of time. But the cosmic
So
rays,
cosmic doesn't mean they're necessarily cosmic.
Oh, it's just
You
the
could do it
name.
in the
She's
lab.
talking about the muons. They last for like six.
I thought
6
cosmic meant it was
microseconds.
in the cosmos.
yes,
Hold on.
talking about
Hold on.
muons. Talking about,
She's talking about muons. They last for 6 microseconds.
So what?
So there's no way they can travel from the top of the atmosphere to the bottom of the atmosphere in 6 microseconds. The reason they do that is because they're traveling extremely fast, and to them, time slows down.
How did you come to this conclusion that time is slowing down?
They've measured it. They've measured it at all these accelerators. Why do you think they accelerate these things to large fractions of the speed of light, and the particles last longer than they do when they're not moving?
Seems to be some steps missing there. Okay, so I accelerate a
What
particle.
steps are missing?
It lasts longer than if I don't accelerate it. Therefore, it's time traveling.
Yeah, basically.
What's the steps in between the observation and coming to the conclusion that it must be traveling through time?
Well, what's your conclusion?
I wouldn't draw a conclusion from that.
Yeah,
that's an
what's your-
observation.
my
That's not
conclusion-
a experiment.
It is an experiment, actually.
Well, actually, it is in a sense because you're accelerating it and it lasts longer, but then you assign the reason that it lasts longer to
It lasts longer when it's
it
moving
time
fast.
traveling. That's
It lasts longer when it's traveling fast, and the faster it goes, the
that
longer
doesn't
it
mean
lasts.
it's time traveling.
Then what else can it mean? Tell me what else it can mean.
I don't know. What did they rule out?
Well, that's a if you want to get pedantic about QE scientific method,
Longer it lasts.
you can say that as you change speed, the time that it exists is extended. That would be the dependent variable. So when you increase the speed, you are changing the time that it exists.
Or how about
So in a sense,
if you
that is time
accelerate it,
dilation.
it just lasts longer for whatever reason, and you don't know why. You just know that if you
but
accelerate
that's
it,
a
it lasts
hypothesis.
longer.
But that's a hypothesis. If we use a Lorentz contraction in this sense, we can move forward with an experiment as Schill explained. So then you have your independent variable of changing its motion, and then you have the dependent variable would be the time that it lasts.
Okay,
or
so
that is measurable
then
or exists.
the cause is of it lasting longer. You accelerated it. It has nothing to do with time travel. Right?
I've been talking a lot.
Keep
Do you
going.
care if I
Hold
chime
on.
in this?
That's what you said the independent variable
Yeah,
was,
keep
right?
going. Keep going. Yeah, keep going.
What part am I missing?
The next part. What does traveling faster mean? What does it change within this explanation?
Didn't I
think of it
explain
as
the whole full thing?
distance,
So you said
Brandon.
I accelerate it and it lasts longer. That was
Right.
your
So-
observation, right?
So
That's your cause
without
and effect.
accelerating it, at rest it will be measurably it'll measurably exist for a short amount of time, a finite amount of time.
Yeah.
But that changes when you speed it up to a particular speed. Yeah.
Okay, and where does the time travel aspect come in?
That'll be the time dilation. So your
No.
I think when you think of time travel, it's like the movies. I think when
Nope,
you
that's
when
wrong.
well, okay, that's what I think. That's all.
Yeah,
Then why
but
you
you're
call it
wrong.
time travel?
I just let you know that you're
Why
wrong.
you call
Keep
this
going.
time travel?
Okay,
According
perfect.
to P. time travel is real.
So what's happening is just essentially time dilation, in which this thing is existing
Wow.
for longer than normal because of speed, and that's
You
just time
have
dilation.
not. That experiment does not result in the conclusion that time travel. You did not identify
dilation.
time, whatever. You
Time
didn't
dilation,
identify
yes, it does.
time travel or dilation as the cause of that muon lasting longer.
What else is it?
The
What else is
cause was accelerating it.
Right, that's the effect that
What
you have
happens
time
when you
dilation.
accelerate?
It's
No,
the
no.
effect.
The cause
Right.
was
The faster it
accelerating
goes-
it. You accelerated it, hence it lasted longer. There was no
Right, what
time
was the
dilation
effect?
involved.
The effect is time dilation.
It
Nope.
lasts longer. What do you mean? What's wrong with that? That's time dilation. It lasts a longer period
No.
of time.
You're missing
Yes.
you're
I can
missing
answer
some
this.
logic in there.
No,
Yes,
I'm not
you
listening.
are.
You are inserting mislogic in there.
No,
Tell
I'm
me
not.
Brandon, I
what else is
can- I
happening?
can
What else am I
answer.
missing?
Hold on.
The faster it goes, the longer it lasts. What's
Chill.
wrong?
Yes, that's it. You got it right there. Time dilation not necessary. I don't know why you're
Yeah,
talking
no.
about time dilation. I
is
accelerate
time
something,
dilation.
it lasts longer.
That's
Chill.
It could
time
last longer for any
dilation.
number of reasons. We don't know.
Here's the proper response. Here's the proper response to Brandon. If your only argument is nuh-uh, then we have no debate here.
If you don't understand the logic and how a scientific experiment identifies the cause and effect, that's not my problem.
This is
I'm not
definitely
saying
cause and
nuh-uh. You're
Yes, you are.
inserting time
This is-
dilation into this, and I don't know how you're getting there.
It's definite cause and effect. The faster it goes, the longer it lasts.
That's it.
No,
that
let
doesn't
me-
have anything to do with time dilation.
Yes, it does.
No, it
lasts
doesn't.
longer. Yes,
You
it
lost,
really
guys.
does. It really does.
On the game.
The faster it goes, the longer it lasts. What else can you assume? Just because what happens when
You
it goes
just said
fast? Why does-
assume. So why did I assume that? You said, what else can I assume? So you assumed it. Why'd you assume it?
And assume it. We proved it.
No, you just
No,
said
that's
assume. You said, what else can I assume?
What else do you assume? As I'm asking. You
I'm
say
not
it's
assuming
time dilation.
anything.
What is
You're
it?
the one who
You
said
have
this
to.
was a scientific experiment.
It is a scientific experiment.
No,
You
it's not,
reject
because
it.
you just told
don't
me you
understand.
assumed it was time dilation.
I asked what you assumed it was, sir.
You said any alternative to your theory would be an assumption, meaning yours is also an assumption.
No, mine is not an assumption. It's being
Yeah,
proved.
guys, hold on. I want to say something, please. What I know about the muons is that the time they come from the upper atmosphere. So is there an experiment that they actually accelerate at a certain speed? Yes or no?
Well,
If
see,
yes-
here's the problem you guys are ignoring. Here's the problem you're ignoring.
James,
okay?
hold on. Crow just asked a question. Crow.
Well, if it is being accelerated in a lab, then there will be a prediction of how long it will last. If the prediction based on Einstein theory matches the life of this muon, then it's confirmed. But not just because it lasts longer. No, it has to be calculated and compared with the prediction.
to a degree of accuracy. Sure.
So you are saying, Crow, that just identifying the fact that if you accelerate a muon and it lasts longer, you can't conclude just from that alone that it's due to time dilation. That's what I heard you say.
No, we didn't say it's due to time dilation.
You weren't talking. I don't know why you're saying we. I don't know why you're saying we, because Crow XE was the one who just talked. Crow XE was the one who was just talking, and I was asking him for some more information about what he said.
Time dilation is a result of.
Why are you still talking, Biodual? I asked Crow.
Because I'm not muted yet. How about that?
Why would I mute you? I just don't know why you're being rude to Crow. Crow, go ahead.
Yeah, like when I do calculations about the sun and say the Earth is a sphere, because I do predictions based on inputs. The input here would be the speed that they accelerated the muon to, and the calculated life based on that speed, and Einstein theory, if it matches the result, if the prediction matches the result, then this is precise confirmation, not just that it lasts longer. It's a little bit slow.
Is that what happened?
Yeah. No, I don't know. I don't know if they accelerated in the lab or not. But I'm saying if it's accelerated in the lab and that was the process, then that would be a good proof for me.
Does anybody have any citations for any of this crap?
Yeah, Einstein.
Einstein accelerated muons in the lab?
No, it's a confirmation of Einstein's theory.
Oh, yeah. We were asking about the scientific experiment that we're describing, and I was asking if anybody had a citation for it.
No.
Can I say something on this real quick?
Yeah.
So let's just say you're riding a horse from Colorado to Utah. Your average speed is, because you got to stop and rest the horse and shit. Your average speed is 25 mile an hour, right? And then you use a Chevrolet Corvette on a high speed interstate, right? You didn't travel through time. You just got to the destination quicker. But it would seem like you did travel through time because of how long it took on the horse, and all of a sudden you're there in the Corvette. You're there. You got all this time in the day left. You see what I'm trying to say? It kind of goes with time dilation. You're not traveling through time. You're getting to your destination quicker and having more time in the day.
No.
But the time isn't changing.
James, no, that's not what they're saying. That's not what they're saying. What they're saying is that if you go up to close to the speed of light, you will actually, let me put it this way. If you're on a rocket ship and you go the speed of light, 2 seconds will pass for you. You'll come back, and a longer amount of time will pass for on Earth. You understand? So you're skipping through time. You're speeding time up.
Yeah, that's what I'm saying, though.
The twin
I think that's
exactly what happened.
It doesn't have anything to do with you are only alive for 2 seconds, and a longer time went by, say years or whatever it is.
Well, let's say you're on the ISS, right?
Okay.
And it's 17,500 mile an hour. So you go around, I guess, twice in a day.
Time
No,
is
it goes
passing
around every
less.
90 minutes.
Passing time
Every
is
90 minutes. Thank you. Yes, correct.
Time is passing
Hold
slower
on.
than the ISS. That's
Yeah,
correct.
yeah, but hold on. The same amount of time, whether it's not like you're traveling through time, right? You're going through day and night quicker
No.
than the people on the Earth, but it's still the same amount of time.
Yeah, that's
No,
different.
actually, time
that's
is tra-
different.
is-
They
is
actually are
passing
saying
slightly
You see what I'm
slower.
saying,
that
Brandon?
you speed up time
Slow it down.
or slow
Yeah,
it
but
down.
you can't. It's all based off the sun and the moon.
No, it's not.
Time
That's all.
passes.
Yeah.
Time
passes.
is based off the sun and the moon.
Time
That's
passes. No, time is based on gravitation. So the
That's not.
closer you are to a black hole, time passes slower. So the
No.
closer you are to the Earth, time passes slower. Up in the atmosphere where the ISS is, time takes place quicker.
I think I see what you're saying. There would be a deviation. I agree with that. Yeah, I see
No,
what
no,
you're
no.
saying.
I don't think you get it at all, James.
But
I
it's
gotta be
not
honest with you. Because
really.
yes, it has nothing to do with the distance or the speed that you're going necessarily. It has to do with the speed you're going, but you're actually speeding up time itself. They think that you can speed up time.
Yeah, but that's why I'm saying they're wrong, Brandon. Based off distance, because if you let's say you go the speed of light for a mile, and that's it.
Yeah. Yeah.
Right? What they're saying is based off distance. You got to be able to keep going and going and going and going and going for,
Yeah,
for
you
a
have to
long
go
amount of time, which we register this here on Earth. It'd still be the same time.
No, that's what I'm trying to tell you. No.
Otherwise, you couldn't deviate the two. It's
If
got to
they
be
have
based off the time.
Listen, if they have two watches, the guy who gets on the rocket ship has a watch on, it says noon. The guy on the ground has a watch on that says noon. The guy in the rocket ship goes out, he gets up to the near the speed of light, comes back. He comes back, his watch says 12:01. 1 minute passed for him. He counted the 60 seconds while he was on the ship. The guy on the ground looks at his watch and it's 1 p.m. An hour went by for him. They think that the faster you go,
yes, it would.
that's what they think happens, James. That's what they think happens. That's what I'm trying to tell you.
Yes, even
I
better.
know,
Brandon.
but what I'm saying is you would go all the way around, right? And it would still be that time on Earth. You're not going to change the time on Earth.
No,
you do.
Time passes slower for him.
All you did is go with the distance.
So
Very
James,
fast.
so James, what happens if you travel an astronaut takes off in a spaceship? He travels a significant distance close to the speed of light. He comes back.
So it's based on distance, Brenda.
Everybody.
You just said significant
based
distance.
on the speed of light. Based on the speed of light. So he comes back.
So you can't just do it in a mile.
So he comes back, and everybody he knew is dead. They died of old age, and he's still 50 years old.
No, they wouldn't.
Yes,
James, I'm very happy. I think it's a good sign for humanity that you're not able to.
The slower your heart beats.
The speed of light.
The faster you go, the less heartbeats you have.
No,
the faster you go, the slower your heart beats.
Therefore,
well, your heart's only going to beat so many times in a lifetime.
Speed of light is constant. Therefore, time changes.
It doesn't.
Oh.
And speed of light isn't constant. James.
Your heart beats the same amount of times.
No,
I just provided an experiment.
Speed of light.
You're going to die at the same age. You're going to.
Yeah, but much later in time. And
no, it's not.
Yes.
I just provided an experiment for time dilation. It's pretty neat. They essentially measured these U-Masons from the top of a mountain to their destination somewhere in Massachusetts, blah, blah, blah. But yeah, real experiment, 1963. They used Einstein's special relativity to make predictions, and they concluded it's all good.
The easiest one done for people to understand is when they took a bunch of atomic clocks and put them on a Pan Am airplane and flew them around the world a few times.
See, I read on that. That's why I'm agreeing with you.
And then they landed, James, they landed those clocks and they compared them with clocks that had been kept on the ground, and they had different times.
Well, they must have fucked
Yes,
the clock up. Because time travel is not possible.
Though, your heartbeat still stay. Listen to me. Listen to me.
Speed of light is constant. Time changes. I know this is hard to understand.
Are you okay? Let me finish, please. So, you're saying that the faster you go, the less times, the slower your heartbeat is.
Had nothing to do with your heartbeat.
Well, your heart is only going to be.
It's not just your heart.
Let me finish.
It's every single atom. It's every single atom in your body. Every atom in your body. Every single atom.
Listen, it's only going to beat so many times.
James.
It's right. It's every atom in your body. Everything experiences time.
That means you're slowing everything down.
Yes.
Correct.
Yes.
Exactly.
Yes. That's
yes, everything is being slowed down.
The clock on the table will
so
tick
your
slower.
heart rate would measure slower.
To whom?
So
not to you. To you, it appears to
the
be
person
the
on the that would.
To you,
if your heart rate ain't any slower, then the time on Earth ain't changing. You're just
Time-
going a
time on Earth changes.
distance quicker.
Time on
James,
Earth changes. Time on
I'm
Earth is
happy you're
faster
not
than
understanding it, James, but you're really not. You're not getting it, man. These guys think that it is going
It's not think,
faster.
it's proven. It's proven, Jeremy.
Well,
No,
I just
it's not.
provided two scientific
proven,
experiments. I just provided two scientific experiments.
What's time based
showing that
off of?
these
What's
that
time
time
based
dilation is
off?
real, and they're using different materials as well. So they're not making the same mistake, perhaps, by using the same materials. They're doing it with other materials. So these two scientific
when you
experiments would be great to read up on.
All right, James, hold on. So explain this as scientific experiment to us. This time dilation. And what's
the
going
first
on
one?
here? No. Let's do
Yeah,
this
so-
one because I opened this one. The time dilation. Here, am I sharing my screen? An experiment with mesons. Is that how you say
Yeah,
it?
I'm not 100% sure what mesons are, but I think it has
Okay.
something to do with the cosmic rays. They went to the top of Mount Washington, New Hampshire.
That's muons.
They were selected.
That's how you pronounce that. Muons.
You know, I think it's mu mason. I think it could be something. I'm not.
Well, the symbol is muons. So they were selected to have speeds, essentially a percentage of the speed of light. So some survived when they reached sea level when they were measured in Massachusetts. I assume that's probably the lab. I'm not entirely sure. But they did have expectations according to time dilation and special relativity. The observed time dilation factor was about 8.8 plus or minus 0.8 to be compared with the effective time dilation factor calculated would be about 8.4 plus or minus 2. Within range of the expected time dilation, confirming special relativity predictions.
So can I ask a question?
Yeah.
See,
So,
what I'm trying to say is,
earlier,
if
Brenda-
you're
Hold on,
going
James.
around the Earth,
Hold on, Rodney. Go ahead.
Well, earlier, Brenda gave the example of an astronaut or someone going up into space and then coming back and everyone they loved was dead as a example of what would happen. So why don't we observe that with the astronauts who supposedly go to space and we live stream video chat with them while they're time traveling?
Because they're not
all
traveling
getting
close to
older.
the speed of light.
They're not
That's why.
traveling, yeah.
I saw that movie, Planet of the Apes. It was really good.
They're not traveling close to the speed of light, and that's essentially what it's based on. The closer you get to the speed of light, the more of an effect that it's going to have.
Right, but the faster you go, the more time speeds up, right?
Sure, but at very
why don't we
low
observe that
speeds,
with them?
compared in relative to the speed of light, at very low speeds, there's going to be negligible differences.
Actually,
Relative-
Rodney, I got to
relative to
correct
us,
you on
we're
one
supposed to be
thing. My
moving.
understanding is that up to the speed of light, yeah. But once you get to the speed of light, time freezes, and then when you go faster than the speed of light,
Well,
time goes
yeah,
backwards.
You can't travel.
You can't travel faster than speed of light.
Yeah.
Oh, that's just theoretical.
As far as we know, we cannot travel faster at the speed of light.
See, you started this conversation saying that Einstein's probably wrong, but it's the best you got, and now you're ending it with saying Einstein's 100% correct. You cannot
Wow, Crit,
travel backwards.
how many straw men can you fit in one
So-
sentence?
All of them.
Perfect. Good
job.
so let's
Great
say you go
execution.
around the Earth.
Yeah, and then you're gonna say that it's the best theory you got, but if someone says, "Yeah, it's just a theory," then you
Not
flip
just a
the
theory.
fuck
Not just
out.
a theory. It's not just a
You're,
theory.
you're just flipping out on the word theory, which shows you don't understand science.
But why did he say?
Well,
Why
Yeah,
did
if
he
you're
say
so if you're
jumping on
going, if
board
you're going around
Einstein
the
at the same
Earth
time
at
you're saying
super
he's
high
wrong,
speed,
Hold on.
that's a you problem, not a
No,
me
it's a
problem.
you problem. When you use the word
No, I
theory,
can sit there and
and
laugh at it
when
because you
use
don't even
the
know what you're
word-
talking about.
When you use the word theory and say just a theory, it proves that you have no idea what you're talking about, sir.
When you
Well, it is
say
just a
something's
theory.
wrong and then go on to explain for an hour and a half how right it is,
Chill. Don't
That's a you
engage
problem.
because he's fighting a straw man. He's not addressing what we've said or our positions. So there's no need to reply.
I'm
to
sorry. This just a theory thing is the
so let me try to be more concise
Wait,
because you could be right.
Hold
I'm
on,
totally
James. Before you
not
go on
getting-
that, I think we cut Rodney off. I'm sorry, James. Rodney, did you have a follow up to
problem.
what you were asking, or were you done?
I don't know. I mean, I still think if their theory is correct, you would see that with the people going to space, right?
Yeah,
Because they're
we
supposed to
do.
be going so fast.
We do see it. We do see it.
Question.
We
I have
see
a
them.
question.
extremely, extremely small.
If
The clocks are
the speed
different.
of light, if the
Right.
speed of light is constant and it's time that changes, what happens to time when they do these experiments where they slow the speed of light down to just like meters per second?
Oh, good question.
Well, I could be wrong, but I thought, according to the theory, that if the speed of one changed, that the other had to change with it, right? Like the space time expands and contracts simultaneously.
Relative to the speed of light, the difference between us moving in a car 50 miles an hour and a spaceship going 20,000 miles per hour, both of those speed relative to the speed of light are essentially negligible. Where it seems like a lot to us, where they're traveling, 5,000 times faster than we are. Oh shit, big number. When it comes to comparing that to the speed of light, that difference is so small.
I think you missed
we
the last
wouldn't
point,
expect
though.
to. Oh, but perhaps I'm sorry.
They were talking about when you slow down light in the lab to where it's going far less than the speed of light. What happens
It's still
then?
traveling the speed of light. It's
No.
There's just shit in the way.
Nope. That's not how things work.
Okay.
So here's my point, guys. If you're going around, let's say you just go around the Earth. You start on January 1st. You go around the Earth 4 times in one day. Does that mean if you're on the spacecraft that it's January 5th?
No,
or is it? Or
No,
did you
dude,
just go around the Earth 4 times in one day?
You just went around the Earth 4 times in one day.
It depends whether or not you're going to the East Pole or not.
No,
well, you
and it
experience night and day 4 times. In other words,
But
does that mean the calendar has changed?
Yeah, the calendar
Or
changed.
you just went? No, it didn't.
What?
Yeah, it did.
No.
Calendar changed.
It's still January 2nd.
Oh no, it's
You
January
just
5th
went
now, so
around
it's
the
been
Earth
4
in
days.
4
You went around the
days.
Earth 4 times, so it's
You
January
just went
5th.
around the Earth in one day 4 times. That's all you did.
Ronnie,
No,
do you have
that's a
access to
stupid
text
question.
chat?
You already have the answer.
James, are you fucking
Ronnie,
with
do you
him?
have access to text chat? All right. Regardless, I'm gonna show speed of light, and then the percentages of spaceship speed and our car speeds. I'm gonna
What
show
is
you
the
the
claimed
percentages
speed of
to see
light
what
in miles per
happens.
hour?
I just looked that up actually. It would be
186,000
per second.
What is it?
So it would be 670 million miles per hour. That's what it would be.
670 million miles per hour.
Yes.
Boy, that's cooking.
Right. So
pretty
that's why I'm
fast.
saying when you have the speed of light being 670 million, the difference between 50 and 25,000 is negligible. So that's why we don't observably see time dilation from astronauts.
Well, that and it doesn't exist, but yeah.
Well, we calculate it for the clocks for GPS and
Actually,
other
it does
equipment in
exist.
space.
I know you guys say you do that, but
Wait,
not
Been proven
crazy.
why would it need to be built into GPS if all of the speed scales that we use don't even get to like a fraction of a percentage close to the speed of light? We would never. There would be nothing in the world that we use to calculate that we would need to take into account time dilation if light moves at that speed.
Do you know how much they adjust it by? What scale?
I don't need to know. It doesn't matter. Whatever
it
it is,
doesn't,
it
it
has to
doesn't
be
matter.
so
Then it
minuscule
doesn't matter.
that it doesn't matter.
If you want to be really precise, it does.
Right. If it doesn't matter
But we
to
don't
you
need
to
to.
know
There's
the scale
nothing
in
on
which
the
they
earth that we
adjust,
would need to be that precise for.
Actually,
If-
the Earth, yes, there is actually.
if you don't care about what scale that they make these adjustments at, then I don't care to respond. How about that?
I didn't say I don't care. I said I don't need to know.
You literally just did.
Actually, you do. If you
No,
want to
I
be
didn't
really
say I don't
precise.
care. I said I don't need to know.
Actually, you do if you want to be really precise, but that's another issue.
But we don't need to be that precise about anything because it's such a small
we do.
percentage.
Actually, you do if you really want to
What
be
for?
really
What?
precise.
What is it that they're accomplishing by being that precise?
They're ensuring the timing for
During the timing, telling you
for
where you
communication.
are, making sure you can land your airplane on the runway, not off of it.
But the planes aren't going at like a fraction of a percentage
Yeah, you're
of the speed
confusing.
of light.
You're
So
confusing
it
many
can't be
different
for that.
principles.
They must be able to do it without that.
You're confusing many different principles, man.
Yep, he's definitely. No, he knows that he's just trying to be a pro.
Yeah. So in summary, I've provided 2 experiments, scientific experiments with very, very thorough explanations, which even hurts my brain to attempt. But it's all there, showing time dilation. The first one I think was 1963, so pretty old news, guys.
What doesn't show?
Yeah, you've got
time
a
dilation.
video here that you showed us
valid
of a couple of
indicator.
guys in a warehouse.
It doesn't show it.
It validates it.
They're doing something and talking about something, and supposedly this validates time dilation from 1963. Okay, we'll check this out. And then I didn't get a chance to look at the other one yet. What was that one?
Oh, the second one, I didn't read much into it. It was I will admit it was a headline reader, and then I think I read some of the abstract and said, "Fuck it, I'll copy paste it."
Oh, okay. So you don't really know if that proves.
Oh yeah, no. I like I said, I'll 100% concede that I read the headline and I read some of the abstract, and that was it for the second one.
Would
And
you
I
say
said,
that you
probably good
Google,
enough.
would you say that you Google searched and copy and pasted a couple links for us? That was about the extent of the research you just did.
Nope. I said for that one specifically. So this is the website that I went to, paulbud.no, and there's a list of a number of scientific experiments. These two come from this source, and I read the ones that are titled Towards Time Dilation. First one I read into said, oh yeah, perfect. The second one I read enough to say, that's probably good, and that was it.
Okay.
I'm going to read into it, I just haven't yet. So I am admitting at this moment in time, I have not read it as much as I read the first one.
I see. Okay. You know, regarding this
I think I'm
GPS claim that GPS relies on time dilation, I can't say that I've really seen any compelling evidence that that's true. Has anyone? Other than just seeing it listed in a website and people making that claim?
Other than the distance it's traveled, it's got that. Once it gets so far, it's got that amount of time to send the signal back to you.
That's not
The longer
what it
the
is.
signal,
Yeah.
the longer the signal, the more. So I don't know. I'm still ignorant on it. I'll admit it, guys. I am, because like I was saying before, the only way to go around the Earth 4 times in 24 hours is to have a 24-hour foundation.
Sometimes
You gotta have
somehow
a-
they think that you can divorce yourself from reality, travel through time, and come out in the future. That's what it boils down to.
If you travel at a good fraction of the speed of light, that would probably happen. Yes. So what?
I'd like to clarify and reiterate what your explanation. I think it's a little unfair to say travel through time, which may not be wrong, but I think it would be better to say Globers claim that these satellites travel at a different rate of time than we experience on Earth. I think that'd be more accurate to say.
A different rate of time. So time is sped up for GPS satellites.
Whatever reference, sped up or slow down, I think it'd be unfair to say through time as if it's instantly into the future or something like that. It's just traveling at a different rate than we experience on Earth.
Yeah. Okay. Sounds like mathematical mumbo jumbo to me. Are there any flat earthers who
Go ahead.
think this might possibly be a thing? Either
I don't
time
think it's a
dilation
thing.
or length contraction. I'd be curious to hear from you if you think there's a possibility that this is.
Of course not. I mean, you guys
true.
barely understand that 1 + 1 = 2. You expect us to understand general relativity?
That's pretty funny because in general relativity, 1 + 1 = 1. You just debunked yourself again.
Damn, Shill, get fucked.
Yeah, I guess I did. Wow.
Yeah, you did. You're right.
Wow.
I want you to say 1 + 1 = 2
Wow.
in Chinese. Say that in Chinese.
1
Let me
+
hear it.
1 = 2 in Chinese. There you go. I said it.
Very good. Very good. Very.
So
You guys-
aren't there two effects with satellites though, with GPS satellites? Because so you would have time dilation from the speed, right? That's special relativity. But then you also have time dilation from the difference from the gravitational fields, right? That's what general relativity says.
Yeah.
Yeah,
you're right.
Well,
I'd have to look into that.
I posted a link in chat against that NASA guy, Edward Dowdy, and he talks about how you could get away with not even doing the change that they have because you follow the theory, like those two things should just offset themselves.
No, they don't.
I don't want to make a solid claim or put my life on it, but I'm pretty sure they make calculations for both and they adjust it by the difference. But let me find a source. Don't hang me by my neck by that yet.
That's what I read.
The only
too.
way you can have a time dilation is if it's different from the foundation time, right? Well, the
Yeah.
foundation
What do you mean
time,
by foundation
you're
time?
never gonna change. You're never gonna change that foundation time.
What do you mean foundation time?
James, in these guys' goofy world, there is no foundation time.
It's all relative. Your reference frame.
Well, what is time? Okay, what's time based off of? What
The
is
reference
time
frame, our reference frame on the
based on?
surface of the Earth.
I never did.
How do
get
you
an
know that
answer.
it's? How do you know that it's noon?
Sun's overhead.
Oh, so it's based off the sun.
Sometimes.
Well, the
All
sun is
right.
based off of our time. We have
So-
what we consider
so
the
when
middle of the
you-
day, and we assign that to the sun because it's easy.
Yeah.
It's easy and consistent. That's why.
Let's say you travel out into your fantasy world and you can no longer see the sun.
That's why we started to make clocks.
What time is it?
That's why we started to make clocks.
Well, it's based off the sun. The clock is the sun.
That's why we started to make clocks, though. When we figured out that the sun is not visible at
The
night.
only way you can have a deviation is by the time on Earth.
Incorrect.
But you're never going to change, no matter how fast or slow you go,
That's
or
incorrect.
what reference frame you're in. You're never going to change the time on the Earth,
Well, that's correct because the time in the reference frame in the Earth passes at the set speed.
which you deviated from.
That's correct because
So
you went
it's your
back- you were in a-
foundation.
You were in a different reference frame.
No,
What if
you're
I-
still, but you're based off the sun. Your time's still based off the sun.
Not if you're going at a significant speed of light. The speed will actually, time will actually pass slower.
No, your
because
time is
light is
based off the
constant.
sun.
The speed of light is constant. Therefore,
It's
time
not.
slows down.
So
to
let's
build
go
on
back
what
to
you're
that. So if the
saying,
speed of-
James, I got a question, then I'll let you go, Farm and Ganja. If I am in this ship and I've got a camera that's looking back at the Earth and the sun, and I go faster than the speed of light, what would I see happening? Since 2 seconds is going to pass for me and 50 years are going to pass for the Earth. What would I see the sun and the Earth doing?
How would why would the
Or let
Earth
them answer that. Yeah.
speed up?
What would
Why
I see
would
them
50
doing?
years?
You would
Well,
see because if you're
this is
traveling
where
speed
I'm
of light,
ignorant.
Hold
Great-
on,
great
James.
question.
Hold on, James.
if you're traveling speed of light, you would see the Earth and the sun basically freeze in place because
Why would I see that? Let's say I'm traveling near the speed of
The
light.
opposite.
That means
That's the
time is
opposite. How you
going.
planning to stay?
More
how
time
you
is
planning to
passing.
stay-
More time is passing for the Earth than is passing for me. So what do I see happening? Because there's the 50 years are going by. So do I just see the Earth just spinning and spinning and spinning and whipping around the sun?
because you're going the speed of light, no information can get to you,
No, I'm going near the speed of light.
and a little bit of this, a little bit of information can get to you.
Okay, I've got technology that boosts the signal. I've got a camera outside of the Earth and the
So
sun, and I've got technology that boosts the signal and sends me the picture in real time. What am I watching?
Faster
What am
than
I
the
seeing
speed of light?
happening? Yep.
Faster than the speed of light.
Yep.
Okay, that's such a
You're
thing.
going warp 9.
What is happening
Beam me
though?
upside.
Warp speed is something different.
Hold on.
Okay,
I don't
let's not
care
get
about warp speed. Do you know what would be happening? What would I be watching the sun and the Earth
I have
do?
no idea because you're
50
now,
years
you're
is
now saying that
passing.
you're now saying you have superluminals radio or something.
Yeah, but whatever is happening has to be happening in reality. It doesn't matter if I can see it or not, right? I'm going near the speed of light. I'm shooting out of the universe.
And your reference frame.
And I'm going to come back
your reference
in. What am I seeing happening with the Earth and the sun? 50 years is passing, so I should see them all spinning and zipping around, right?
No, because the speed of light, the information is coming to you at the speed of light. If you're going a high fraction of the speed of light, you're not going to see what's happening there at this moment. Because
You're dodging the question.
No, I'm not dodging the question. You don't understand the question. What you're asking.
I do. I do understand the question. I'm
There's no
asking
way-
what is happening in reality.
There's no way for you to get the information faster than the speed of light.
That doesn't matter. It still has to be happening. In order
Well,
for
he didn't
50
say
years to
faster. He
pass
didn't
on
say
Earth,
faster than
the sun
sorry to
and
interrupt, Brandon,
the
but
Earth has
he
to
didn't
be
say faster
spinning.
than the speed of light.
He's talking about seeing the information. He's talking about seeing the Earth as well. He's going, at the speed of light, and you can't see.
Okay, forget about
You're
being able
going-
to
you're
see it.
going
I'm
away from it.
asking
The
what
light
the
can't-
fuck is happening.
The light can't hit your eyes. You can't see it happen.
I don't care if the light's
but
hitting.
your time dilation is
guys,
from the Earth.
you're missing my point. What the fuck is happening in reality? I'm shooting out near the speed of light. What is happening with the Earth and the sun? The Earth is flinging around the sun, and the sun's and the Earth's spinning.
To everybody on the Earth, everything just appears like normal.
No, but the Earth has to be spinning, and it has to be rotating around the sun in your world, right? So it has to do that 50 times while I'm gone on my little trip.
Yeah. Okay.
Okay, so that's happening. Everything is going super speed behind me.
No, because in their reference frame, everything's normal.
So if I could see it, I would see it going. If I could see it, I would see it going super fast, though, right?
But you can't see it because the speed of light is the limiting on the information.
Yeah, no,
So what
you're
if I
right.
can't see
Everything
it?
else for you
Well, then
would
how
have
do
to
you
look
know
like
what you're
it's going
saying is
faster.
true?
Right. It would all have to
How do
look
you
like
get
it's
a
going
time
super
dilation?
fast.
No, because you can't see it.
You're dodging the
Well, then how do
question
you know how
by
fast it's going?
acting like it matters if we can see it.
Okay, to the
Is
people.
he under the impression
Listen,
that things only
hold on a
move
second.
if you can see them?
I think so.
No, hold on for a second. You don't understand your question.
He doesn't understand his question.
He doesn't.
Wow,
that's
what an
correct. You don't
argument.
understand your question. Now shut up and listen for a change. To the people. on the
Why?
reference
You're
frame-
talking nonsense.
I'm talking. No, sir, you are. Listen to me once again. To the people on the Earth, time passes normally. The fact you've gone off on, everyone said bye to you, and you went off on your speed of light journey. Nothing happens. The next day, they all wake up. Nothing has happened differently.
Dude,
Yeah, we already understand that part.
I'm talking about. Okay, then, if I could see the Earth and the sun, the Earth would be spinning super fast and rotating
can't
around the
see
sun
it,
super
though.
fast.
No, you can't see it though. That's the thing. You can't.
So
get
fucking
information.
stupid. It just gets dumber and dumber.
Let me help Brandon.
I
real
get dumber
quick,
and
'cause
dumber. No, because
let's
the
say your
information.
trajectory.
Hold on. Will you
is
shut up,
headed
James, for
towards
just
the
a
Earth.
moment? James, will you please just shut up for a moment? Thank you.
You want
If your
everybody to shut up?
trajectory was
James,
headed
please.
towards
Master
the
How come
Earth.
how come you
This
don't
guy
yell at
is
him?
full of shit.
Yeah, right.
You're nobody, right? You're just
You
spouting
cannot
words.
get information faster than the speed of light.
How do you know that? Prove it. This is wizardry.
Actually.
Prove
Please,
it.
guys, let me say this because it's going to hurt him really bad.
I doubt it.
If your spacecraft traveling at the speed of light, its trajectory was going to hit the Earth, well, then you're going to hit it because you're not going to see it. That's what you're saying.
Everyone speaking theoretical nonsense.
If you're traveling to there,
No spaceship is going to
Just
speed
said
of
that
light.
you're not gonna
Actually,
see
no.
it.
Listen, what
You're
he's
not gonna
saying
see
is
it.
that
That's
you
what you're
couldn't hit it. If you're traveling at the speed of light, you could not hit the Earth because it has to be moving through time fast enough to dilate time for you for when you get back. So you would never reach it. It has to keep moving faster than you.
So if you're traveling in
More
space
nonsense.
in the fantasy,
No.
you're traveling in space
you
at the
guys have
speed
no
of
idea what
light,
you're doing.
and you can't
I
see.
know we
You're
shouldn't have gotten
traveling
into this
so
discussion.
fast,
At
you
least
can't
you
see if you're going to hit something. How do you avoid hitting?
Hey, Peyton Nasa Shill, it's a real problem when you try to apply logic and reason to this stuff. It seems
problem
to
is-
really bother you guys when you try
No,
to
the
think
problem-
through these
problem is
dumbass
your
things
logic-
that you say.
The problem is you
applying
don't
logical
understand.
reason, or you're applying straw man.
Because he's not talking reality.
The
He's
problem is
talking theoretical
it's
nonsense.
difficult to understand stuff.
fantasy?
The speed of light is constant.
Theoretical or not
So
is
you
not
keep you
irrelevant.
keep making the assertion that the speed of light is constant, right?
That's
But
correct.
we know that's in a vacuum, and when the speed of light goes into different mediums, it
So what?
actually it slows down from our reference point, our observation, right?
So
So what happens to time then for the speed of light when it slows down? Does it speed up? Go backwards? I mean, so they've done experiments, right, where they've been able to slow time down to just merely like meters per second, a huge percentage change. So if you were light, what happens to time when you slow down that much? I know Kosho gave the example of Santa Claus delivering presents, in two different places where he had to make a lot of stops versus very few stops. and yet it always took the same amount of time. If the speed of light, if time is dependent on the speed of my brain gets all hurts trying to think of the logic here. But you keep saying that it's time that changes, not the speed of light, because it's a constant, and yet we know that we can change the speed of light, then we must be changing time. Right?
Go with that. Yeah, why not? Go
Okay, that's an interesting conversation, but what this conversation will actually need to explore is what happens when light, what gives things different refractive indexes, right? What makes light slow down in a different medium, right? That's what actually that process, what the mechanism of that is, has actually has to be explored in
So I
order to
understand it was
make derivations.
You mean the medium? That one?
It doesn't.
So have they actually proven that they can slow down light?
Of course they haven't. No.
That's what the common basis of agreement seemed to have been right now in this conversation.
Yeah, we brought it up before. They've, we didn't look too closely into it, but
It's not agreement. It's willing to allow something for the purpose of discussion. That's not an agreement.
Yeah.
No one has ever shown that they can slow down
Okay,
time or
yeah,
speed it
but,
up. They haven't even measured the
yeah.
speed of time or the
Fair
speed
enough,
of light.
fair
They
enough.
can't.
You don't necessarily, you just entertain the
Actually,
thought,
just
don't
be like,
necessarily
oh,
agree with it.
pretty constant.
Then bringing up the question of evidence when the statement is made about, okay, but what happens when if light slows when light allegedly slows down in a different medium? Bringing up the question if that has been sufficiently evidenced is still moving the goalpost then, right?
how is it moving the goalpost?
Well, it depends on what you mean. If somebody decides to entertain one thought and then they decide that another thought, they're not willing to entertain that thought right now and they want proof of it before they go into it, that's a personal decision they can make. It's not like they have to have the same set for every thought you decide to discuss. You can decide to allow something in one conversation, then not allow it in another, depending on who you're talking to.
Sure, it still moves the goalpost from what we were starting to talk about.
I wouldn't call it that, but I mean, I guess if that's what you call it, sure.
All right. Anyway,
I would
thought it
call
was
it
an
like
interesting
deciding
point that
there's some sort of limit on the conversation. Otherwise, I mean, if we're just going to allow everything, then there's no limit and there's no reason to have the conversation because everything's allowed. You can say it's all due to the invisible green goblins. They all do it.
Well,
The conversation's over.
According to the heliocentric model, the light from the sun hits the Earth. Correct me if I'm wrong. I believe it's 8 or 8.5 seconds, or is it minutes?
Minutes.
It was like
8
minutes.
seconds or
8 minutes. I think
8 minutes, right?
Minutes is
8 minutes.
is
8 minutes. Okay, we'll go with 8 minutes. Right, that's traveling at the speed of light. So back to Brandon's point, you would have 8 seconds to see the Earth and then the sun, like at that distance. So the Earth would be a shorter distance. You're gonna fucking run right into it.
What? What?
You see that? You guys are acting like hold on. The only way that the light from the sun can reach the Earth in 8 seconds is if that 8 seconds or 8 minutes. I'm sorry. Thank you. Or if that 8 minutes is based off of a 24-hour foundation.
Oh fuck.
James,
It's only going to. How do you calculate it? How would you
Oh
calculate?
my god. So if we
So you have 8 seconds, right?
Minutes.
8 minutes. Think of where I'm going with this, though. You guys are just ignoring me.
So you're saying
I'm trying to understand what I'm saying.
There's
so
something missing.
If the Earth had a faster rotation rate, we would call it, I don't know, a minute would be shorter because the Earth rotates faster.
But the
It would
light
only be 7 minutes or something. Come on, it's all.
Can
I suggest something to you, James?
Hold on.
Something to you?
From what you're saying is in that 8 seconds.
Before I go crazy on, I'm gonna.
Okay,
James, can I suggest something to you? I just want to suggest
Brandon,
something
hold
to you.
on. Hold on. I have to say this, Brandon, please.
Okay.
That in that 8 seconds, right? 8 seconds or 8 minutes. 8 minutes.
Minutes.
Right?
Yeah.
That's time. So in that 8 minutes, you're saying that a couple years have went by on the Earth.
Yes, that's what they think.
Then how do you know it's 8 minutes?
Huh?
It doesn't make
How do
any
you get your?
sense. This is what I was going to
Where
suggest to
does your
you.
foundation?
Oh,
How do you know it's 8
to
minutes?
an observer
if the light
traveling
is
close to the
actually
speed of
traveled,
light,
or
and
if
that
the
8
Earth
minutes
is
a
when?
much bigger time passes? Is that what you're referring to?
That's what you guys are saying. That the Earth is what speeds up. See, to me, if you was to travel fast in time, the Earth would slow down.
What speeds up and slows down is dependent on the perspective. It's dependent on
What
the
about if
observer.
light? There was no speed of light. It was just kind of
But it's
omnipresent.
still 8 minutes.
And
That's the whole point.
and
That's
time was a
It's
constant.
8 minutes.
Just constantly go through a 24-hour clock. I mean, what's the problem with that?
Let me just say
that's
something,
why it's
okay?
called-
James, let me just say something. It's a good sign that you're not able to reconcile these things in your brain. It means that you're not double thinking, and I can appreciate that. You won't be able to reconcile what they're saying. That's the conclusion that I've come to. It won't make sense. It just
What
won't.
won't make sense?
Thanks, man.
You can't speed time up and have it go slower for something else. You just can't do that.
How did you falsify that? Because according to what I can find, and I'm admitting that I did not personally verify that, but there is allegations that there is evidence for time dilation.
How did you
taking place.
falsify any of your space calculations? Distance.
It has
light.
nothing to do with space.
Oh, light has nothing to do with space. Okay.
Here's my opinion.
Didn't
This
say that.
violates one of the fundamental building blocks of reality. Okay?
Really?
It leads to contradictions. So
what contradiction?
My argument is that for one set of people or one observer and another observer, time can go in at different speeds. It's nonsense.
Sorry.
Why?
Well,
been
like my example.
observed.
So when I asked what they would see when they're looking back out the ship, what's your answer?
It depends on what they're looking at, right?
They're looking at the Earth and the sun behind them. They flew out at the speed of light. Now they're looking behind them at the Earth and the sun. Let's just say that they can somehow see what's happening. What is happening?
How would they be able to see? So I'm assuming you're talking about someone that's traveling like very close to speed of light away from. Okay. How like the speed of light is right? The speed at which light is reaching you, right?
Okay. It's the 186,000 miles an hour or whatever, right? Or per second, whatever it is.
Meters per second squared. Yeah.
Thank you.
No, not per second squared. That's acceleration. Get your units right.
No, he said meters per second.
Square.
Anyway, we all know the speed of light, the recognized speed of light in a vacuum. Okay, you're going near that.
Mm-hmm.
So what are you seeing behind you? What is the Earth and the sun doing? Well, you're going near the speed of light.
What you're seeing behind you is light reaching you.
What does the light? What are the Earth and the sun doing?
He's slowing down.
What are the Earth and the sun doing? They're chilling.
No. You when you come back, it's going to be 50 years in the future, just for argument's sake.
Mm-hmm.
You're only going to have 1 year pass.
Mm-hmm.
What are you seeing the Earth and the sun do?
Well, they should. I guess they should be traveling relatively fast.
So you're going to see them zipping around each other as you're flying away from them.
Can't see them because light is the speed of information travel. There's no way that anything can reach you faster than the speed of space.
I'll tell you exactly what happened. When you move away
Then
from
where
Earth,
do you get your time dilation?
when you move away from Earth,
That is how you get your time dilation.
Well,
When
if you're
you move
traveling
away-
at the speed of light,
Hello,
Go ahead,
at the speed
Chaiki.
of light,
third time I'm trying to
you
talk.
cannot detain
Chaiki,
any.
go ahead,
The third time,
Chaiki.
James, I know it's hard for you, but it's the third time I'm trying to say something. So when you move away from Earth, obviously the frequency redshifts and you see the Earth slow down. When you turn back, Earth clock start to speed up. It moves in about the normal rate for some time.
You wouldn't see it speed up, yes.
And then at some point it will speed up tremendously. That's if you look through light. That's what will happen.
That's what it'll appear to do because you're running into the light coming faster. See, this is what I'm saying. This doesn't make any sense.
No,
This is a contradiction. I'm observing something. Listen to me. I'm observing something that is going.
Sorry, Brandon.
That is going through time faster than I am. It's not possible. It's a contradiction.
Not all the time.
You're
It
arguing
is.
facilities
Why is it okay?
No,
Brandon,
he's right.
first of all, but
Here's
we're
the
arguing from.
contradiction.
Hey,
First of-
Brandon, can I have a conversation with you real quick? Brandon, just you and me real quick. It's not going to take that long.
Okay.
Do you remember, I think it was yesterday or 2 nights ago, when I said that the argument that we were having about the topic was 2 or 3 steps behind the major premise, right? So we're arguing about minor claims that depend upon something that is greater. I want to suggest, because I've been listening to this the whole time, and you guys are arguing about steps C, D, and E. When you have to, what is the major premise based on? And you have to tear that to the ground. Tear that to the ground. Not these other tertiary small shit, like the stuff that James is trying to wrap his head around, and you and I both saying this doesn't make any sense. What's the first claim that was made? What is that first claim based on? And don't move away from that topic. That's it.
Foundation. Let's go.
I think we're still on the first claim, which is their claim is that you can speed up or slow down time depending on how fast.
Based on what? No. Based on what? Right. That's a secondary claim. That is a.
First, they have to attach.
He told you what it was based on. You cut him off. Based on speed, right, Brandon?
Yeah, based on your speed.
You said it.
That's their claim.
No, because
of what?
okay,
Yeah,
look,
speed of what? Yeah, come on.
Yeah, because I'm driving right now. This is what James was saying earlier with traveling on a horse or traveling in a car. You're not changing anything except for the amount of time it takes you to get from one destination to the next. Okay, You're not changing time, right? It's just taking a shorter amount of time. You're doing it. You're like playing it at
no, you're
twice.
You're roboting.
Or you're listening to YouTube. You're listening to a YouTube video at 2.5 speed. You're not speeding up time. You're just listening to it faster. Okay.
right. Which I would agree with, but that's not what these guys think. So my argument is that this is a contradiction. You can't have. You're essentially saying that two things next to each other can move through time at different rates.
Mm-hmm.
That's what you're saying on a galactic scale.
Exactly.
That's what would happen. We would see the Earth and the Sun spinning around super fast in a ship flying away and coming back.
In your statement, you're implying that time is separated from the spatial directions, right? The movement through time is separated from the movement through spatial directions. That's not what implied, though. That's not what's claimed, though.
That's not a claim. That's just the way time is a concept. So it can't be connected to spatial movement because it's a concept.
Yeah. What's time again?
So evidently, it seems to be connected to each other. They seem to
what
be
time?
interconnected.
You're saying evidently, but there's no evidence of it.
Yes.
No,
so
not
time
evidently.
dilation does not happen. How did you falsify it?
I don't need to
I can-
falsify it. I don't have to
can
prove that it
entertain
doesn't
your
happen.
idea.
You would
There
have
are
to
claims
prove
to
it can
evidence
happen, and you
for
can't.
time dilation, right?
Falsify,
You do know that there's claims for evidence for it, right?
Yeah, but who cares? How are they proving their claim?
There's papers
I
on
do not
it,
have to
and
prove
there's
the
measurements
negative.
of
You
it,
would have to prove the
and
positive. You cannot
those
prove
are
that time
those are
dilation
positive,
happened.
those are positive statements that you can falsify and debunk and prove that they are not true.
What?
Okay, so there is statements and alleged measurements and stuff, right, that show time dilation, right?
Alleged measure? Yeah, okay. There's all kinds of alleged stuff out there. What's your point? Alleged.
Can you please let me finish? Thank you. And you can take them and debunk them and show that time dilation does not actually happen, right? You can very easily falsify that time dilation is not true by falsifying and debunking the evidence that's alleged for it.
You don't need to.
So you're just
You do,
denying, right?
because there's evidence alleged for it.
It's just the concept.
You don't. You don't need to take every claim that's made and then somehow figure out a way to debunk it.
It's not a
If
claim.
it's a positive claim, they have to prove that it's so or it's not so.
There's alleged evidence, and if you claim that it's not true, then you need to show how that evidence
No,
is
I do
false.
not. Absolutely
Yes,
not.
you
That's
do.
incorrect.
No.
No,
You
I do
have
not.
denied the evidence.
I
No.
absolutely do not. No one ever
that's
has
bullshit.
that responsibility ever,
Then you're arguing
ever.
from
Especially
then
when
you're
something
invincible-
violates
then you're
the law of
arguing from
non-contradiction.
invincible ignorance, and your statements can be discarded without any evidence whatsoever.
Same with
What I'm
yours.
saying is completely irrelevant. And
You can
because you're
say
not
something
willing to
is not
consider
true,
the
and you do
evidence,
not have to show
that's-
any
that's
evidence
being-
for that.
That's
Yes,
being-
you do.
That's being
No, you don't. It's a negative
All
statement.
All right, hold
you're
on,
not
guys. We're all
willing to
talking over each
consider
other.
Evidence that's in existence with regards to the
Brendan,
topic.
you
I
have a
do not have to
flipper.
prove
I'm
that
gonna
Santa
flip.
Claus does not exist.
Yes,
you have
you
to
don't
prove
have
that he
to,
does,
but you're
or he
arguing
doesn't
from
exist.
invincible ignorance then.
I'm going
And
from
that's
natural
You can't
completely
prove that he doesn't
invalid.
exist.
That's
I'm gonna
not
flip.
part of a rational discussion. That's not
You
part
can't
of
prove that Santa Claus doesn't
sound
exist.
reasoning.
So according to you, he does until we prove that he doesn't.
I'm gonna
Right?
flip real quick, Brandon. I'm gonna flip real quick. We're going
You
from
can't do
natural
it.
science to
Hold on,
political
Aaron.
science, and I'm gonna flip real quick. I only have one question to ask. I think it was Chaiki, right? Is how do I verify that, Chaiki? Because I'm gonna flip. I'm ready to go. I'm on the edge.
In the chat that
How do I
have been
verify what you're saying?
2 experiments in chat that have been provided, showing time dilation in 2 different and distinct experiments.
So Chaiki did some experiments. Is that who did them, or who? How can I do my own experiments? Because I'm ready. I'm on
How
the
about
edge.
you read
You know the
experiments
fence.
and reproduce their methodology?
Cool. So what methodology are you talking about? Do I need to look up? Do I have to look it up, or can I go out and?
There are 2 links in the chat. I'm driving. It'd be cool if someone can repost, but 2 have been provided in the chat.
Your mic is not that good.
They have to accept the existence of every god that's ever claimed, then, because they can't prove that they don't exist.
I'm willing to flip, Bob Dole. Like, look, I mean, the arguments is coming in so hot. I'm ready to flip, Bob. Just how do I verify it for myself? Like, can I even,
Phase 1,
one little
verifying for yourself. Do you mean personally? Okay.
For humanity, let's say, or just me. We'll start with me, but let's go. Yeah.
Okay. So if you just regard knowledge, if you're only considering knowledge, what you have been part of or what you did verify personally.
Sure. Same knowledge as you. We're good. Yeah.
Also known as verification.
Then that's called the Socratic method, right? And the Socratic method.
No, that's not the Socratic method at all.
Okay, then it's not the Socratic method.
Your whole argument is appeal to authority.
All right, let me.
No, it's not. Like, it's not
Just give me some verification.
What he's actually asking is, do you believe things you can verify yourself, or do you believe things that other people tell you?
I'm being derailed here. So
I want to go light speed. Chaiki.
All right. Are you interested in what I have to say at all?
I'm not.
Yeah, I am, but I want to show you something. I want to show you something,
honesty.
though. I want to show you something. Yep. So I want to ask you this question. This is what I mean by a contradiction, okay? Here I am. I'm God. I'm looking down at the Earth and the sun. This is not to scale. Here's my rocket. Can you see my screen? All right. I get in my rocket. Here I am in my rocket. This is or the guy gets in his rocket. I'm God. I'm watching this. Gets in his rocket. He flies off. He goes near the speed of light. I'm watching all this. Goes near the speed of light. Then he turns around. And he comes back near the speed of light. Right? What did I see the Earth and Sun do during that time? I'm God, watching.
I don't know.
You saw it slow down and then you saw it speed up.
Why would the sun and the moon, why would the sun and the Earth slow down, but this just, went near the speed of light, went back near the speed of light? Why would I all of a sudden see these two things speed up just because this one moved?
Because you're not getting the information from the photons leaving the Earth and the Sun as quickly when you're moving away from it. And when you're moving towards it, you're getting the photons from those two things faster. Therefore,
I think you missed something.
No, I'm getting all information instantly.
He's not on the
I'm God. I'm God.
He's not on the spaceship.
Hold on, guys. Hold on. Let me clarify. I'm getting all the information. I'm seeing everything exactly as it happens. I'm God.
Yeah,
we're not dependent on the speed of the light getting to me.
And God,
he is a third party.
All right, so let me repeat myself because you guys might have missed it. This is what I'm saying is the contradiction, okay? Just bear with me. The guy gets in the ship. I watched this happen on Earth. He flies away near the speed of light. I see the ship. It's still in my field of view. I'm God. I'm watching everything happening in real time. He comes back. What did the sun and the Earth do while he flew out?
What did those balls do?
Yeah. What did I see them do?
What kind of God is
exactly,
it?
actually. I would need to refresh.
Needs to wait for time to see things.
Chaiki thinks he has an answer. Let's hear Chaiki. You think you have an answer? Go ahead, Chaiki.
God knows everything all the time. He doesn't see that move. It knows where
He's got a non-answer. He's not answering your question.
Because that's stupid, the question.
Does anybody have an actual answer?
Brandon, stop playing with balls and put a rocket.
Hold on. I want to know if anyone has a legitimate answer,
Brandon,
a real answer.
Can we establish our baseline a little bit? Like, you God. Okay, so what does God do in this example? Like, is God
Observe.
like the Almighty?
Observe.
Brandon, it doesn't have to be that. Just change it. You're on a spaceship out in space and you can see this happening. There.
God observes. There you go.
You're a human.
No. I am God. I'm seeing everything because I have to be looking down. I in real time, okay? I'm getting all the information. We don't have to worry about the speed of the light from the objects reaching me. I'm seeing everything happen in real time. So let me say it one more time. The ship goes away. I'm watching it happen near the speed of light. Comes back near the speed of light. What did I see these two things do?
When you, from the third perspective, from the point of view that we're at right now.
From God's point of view.
Okay, you would see.
The two.
Wow. Okay, that's an interesting question.
Sure it is.
Did you try to investigate this independently?
Sure, he's God. He doesn't have to.
Do you understand? Because I've said this a couple times. I want to say it one more time. Why I'm bringing this question up. This time dilation violates the law of non-contradiction. I'm showing you the contradiction that I'm referring to. I'm trying to get you to understand it. Do you understand what the contradiction is? Because you said it's interesting.
No, I actually don't. What's the contradiction?
Well, that's for another show.
This
so
has,
you can't
in your model, this guy has a certain amount of time that passes. I watch everything he does, and then he comes back. When he gets back, these people on Earth are supposed to have a longer amount of time go by. In order for that to happen, this little ball you think you live on has to go around the sun however many times and spin around. Why would I see, from my point of view as God, things accelerate here just because this ship is flying away. I'm watching 2 time frames at the same time. How the fuck can that happen?
No, the third observer. That's you. The third observer is also relative, right?
No.
There's only one observer.
When the ship travels away for.
We're not talking about Earth.
Hold on, let him. Let's hear what his answer is. Go ahead.
Okay. When the ship travels away from the Earth, from that Earth, it also travels away from that third observer, right?
He can see it. He's God. He can see it. He sees it go out here and then come back.
Yeah, I'm not saying he can't see it, right? But it also travels away, right?
Yeah. In proximity, if God is positioned here, this goes over here. This is all it does. This ship goes over here, comes back here.
Mm-hmm.
So he sees the whole thing. Everything's in his field of view at the same time.
Mm-hmm.
Yet time is going differently somehow, just because this object is moving over here at a certain speed and moving back here. Why is time changing for this?
Time's not changing for God. God sees everything happen according to him.
Was a good answer.
No,
Say a special plating brand.
Does anybody have an actual answer? This isn't. I don't care. You can call it special pleading at all if you want.
No,
this is a
you
contradiction.
have no idea how nonsensical this question is at all. Is the ship moving?
It's not.
Let me ask you: Is the ship? Is God move with the ship or with the earth?
He doesn't move at all. He can see all of it happening. He's far enough away to see everything happen.
If God see the ship moving, that means he is in earth frame of reference. If God see the earth moving, that means he's in the ship frame of reference.
He's really far away, watching all 3 of them at the same time.
What the hell does this mean?
That's a bad answer, Chaiki. That's not a good answer.
It's not a bad answer.
It doesn't. Stop talking, please.
No, you stop talking. It's not a bad answer.
Because
It's not an answer at all.
Because that's how it works.
So,
you can't say God see.
The problem is that you don't seem to be an expert on special relativity.
I am actually.
We have an
if
expert.
God see
at the very least, you can't explain
moving,
it at all.
that means he's in Earth frame of reference. Otherwise, he won't see the ship moving. He will see Earth moving. This question you ask, assume there is a God that has some kind of special frame of reference that is not dependent on anything else.
Chaiki, what's the third equation?
That doesn't make any sense. That makes no sense whatsoever.
Sounds like
yeah, I want to hear more. What does he
Give me the equation, Chaiki.
Where God is.
The reference point of the person on the ship is a special reference point too. It's not something we actually have.
So, just a question.
Hold on, guys. Let's give. I'm sorry. What's your name? I'm sorry. What's your name? The guy with the cartoon character. What's?
You can call it me
Morty. Morty. Yeah. Let's hear what you have to say because you weren't happy with Chaiki's answer. Okay. So what did you have to say?
So Chaiki, I got a question. Why the ship was traveling close to light speed, right? And was traveling back from Earth, away from Earth, and then back, right? So if somebody is seeing the Earth moving, why would they not be able to observe the ship moving?
That's what I'm asking. Where God? Where is God? What is moving for God? The earth or the ship? Which frame of reference God is? How does he observe
what you're
things?
trying to say. This
How
is what
does
you're
he
saying.
observe things?
You're saying that when you watch the car go by on the highway.
Hey, James, let these two go
frame of reference?
Okay, so what I remember, like we were having a class on this on special relativity, and it is pretty pretty tough to get into it each and every time, right? But I'm just gathering up my thoughts on what I remember about it, right? So the best way to wrap your head around the causality of things, right, and the observation from different observers for the same event in special relativity, when special relativity is has an effect, is a thing, has an effect, and then the best way to do that would be to work in a Minkowski room, in a Minkowski space. Did you come across that term before?
No, what's a Minkowski space?
Okay, the Minkowski space is basically like, you know how, you know the Hilbert space?
No.
Okay, the Hilbert space is basically your standard orthogonal coordinate system, right? Where you have like an x and a y, and with a right angle between them, and sometimes you have a z with a right angle to those two, right?
Okay.
Now, in a Minkowski space, you have a different geometry, right? You have an x-axis and a y-axis, and the y-axis is actually the time, a time axis, right? So an observer that doesn't move, which would be in the Minkowski space, would be represented by a vertical line, I think, right? And you only and the direction that you're looking into would be the x-axis, right? You're simplifying the problem that you're looking at into a 1D problem, right? You're simplifying it into the line of sight, basically, into the direction of looking, right?
From a single observer. I've simplified it from a single observer's point of view of all three of these objects.
Yeah. So, and when you do those kind when you start working in a Minkowski space, I mean, like, you can also make a rendition where you have a tensor for the directions, so that you can actually work with 3D directions again, right? But it gets much more complicated.
You sound like a programmer, like you program computer games
then you
and
would
stuff,
be
right?
using software for it to
Have you ever?
Okay, hold on.
What you can do is what you can determine with this pretty easily is which events are possible, what is possible, what's not possible, right? What breaks causality, what doesn't, and you can also figure out the what happens from different observers for a special for relativistic events, right? For example, something I remember was a Santa has a slide, right, and he wants to get it into a barn, but his slide is longer than the barn. So he got the idea, hey, what about I run into the barn like with really fast, close to light speed, and that would compress my slide, and you just close the barn doors the instant I'm in, and that way the slide would end up fitting into the barn, even though it's longer than the barn itself, right? And then you would consider, okay, what happens from the point of view for Sander when he drives into the barn? Well, the barn elongates, so no, the barn also compresses, so the slide still doesn't fit into the barn. What happens from the point of view that of his colleague that's supposed to close the barn doors, and from the point of view of the colleague, the slide elongates, right? And with the Minkowski space, with this diagram where you simplify the problem into 1D and have a time axis on the vertical, you can figure that stuff out, right? Without having to break your brain about it, right? And there is no such thing. I don't remember any contradiction like this appearing. Like we discussed stuff like this, but it ended up working out from a different perspective. It just wasn't intuitive, right? But saying it's false because it's
So it
not
works in
intuitive
one
to you.
dimension.
Okay, here, let me just kind of summarize what I think I heard. You have some kind of framework that you discussed in the past that gives you some lens of looking at this and processing the information that makes it make sense to you. Don't exactly remember, but you did remember the example of the sled. It's observer dependent, and it was I'm going to be brutally honest, a very unsatisfying answer to the question.
If it's unsatisfying or not is not.
I mean, no
Brandon,
offense.
I got you.
No offense.
I
but
got you. I got you, Brandon.
Yeah, no offense taken.
Okay.
Brandon, so from God's perspective here, nothing changes with the sun and the earth. The earth continues to rotate at the same rate. Before this spaceship traveled at the near speed of light, the sun still does its thing, still revolves, everything, blah blah blah. What it's going to see is the rocket ship travel near the speed of light in a particular direction, and then it's going to that has no effect on what God's seeing between the earth and the sun. And as the spaceship returns near the speed of light, again, what God sees with earth and sun has no there's no change to it, because God is not traveling at near speed of light. If you're on that ship, that's when things will change, because you are traveling near the speed of light.
But then that means that in order for this person to come back, goes out, comes back, these people have lived for a longer time than this one, right? So there's 50 years would have had to gone by, which means that in the time it took this one to go out here, this sun would have had to go around 50 times. So he needs to have seen that and seen this ship just go out here in the time it takes to travel out there and come back.
No, because what's happening is, if that rocket ship travels an X amount of distance near the speed of light, then it immediately turns around, travels that same distance near the speed of light. You're canceling out that time, because you're slowing down in one direction at a fixed rate. Then you're speeding it up by that same rate going back, and it's the same distance. So you're canceling that that time dilation out by doing so.
So then the time dilation didn't exist for this ship. But okay, what if I froze time when he's out here? Goes out here, right?
So from the rocket ship's perspective, with reference of Earth and Sun, time is slowed down. Yes, at that point. God's perspective is time has remained the same rate the entire time. From Earth, time has remained the same the entire time. There's been no change. But right now, with the rocket ship near the speed of light, goes an X distance, time has slowed down in reference to the Earth and Sun. Yes.
You don't see any contradictions in what you just said?
No, that's not true.
No,
that's not true. That's not true. At that point, SC, the ship clock slowed down. The ship C, Earth clock slows down. That's special relativity. Both see the same. There's no special preferred reference frame. Both see each other clock slows down as they're moving away from each other or towards each other. Doesn't matter. Doesn't matter.
So Chucky, let me just clarify, because this whole example we've been using this whole time is about a guy who gets in a rocket ship, flies off near the speed of light, comes back, and more time has passed on the Earth and less time has passed for the person who was in the rocket ship. Now, what BioDuel just said nullifies that example. It's a nonsense example at that point, because you just said it cancels out. He goes out here, slows down, turns around, speeds up, slows down, and the time dilation that happened on this trip out and back cancel each other out. So it's as if the time dilation didn't happen at all.
Yes, of course.
No,
because in one, no, Chucky, shut up. Because in one instance, you are in that frame of reference, if you're on Earth and you're measuring in real time somehow, just fucking somehow, you're measuring the clocks on that ship. When it's moving away near the speed of light, those clocks are going to slow down. And then let's just say it goes a distance in which you know that those clocks have slowed down by 1 hour. Now it does the same track back towards Earth. Now you're going to see those clocks speed up an hour. So if you go the same distance at the same speed, and then you turn around, go the same distance, same speed, yes, of course you're canceling it out.
Yeah, but Brenda said the astronaut's family died while he was gone.
Okay, in extreme examples like that, I'm not sure what would happen. It would just be more complicated. I think what we're talking about is just the principle of it. But
they would die and
like
come back to life.
Let's say it does go 50 years. Ooh, yeah, that is interesting. Hold on.
Okay, so then you're not sure about what you just said about it canceling each other out.
No. The principles are sound. I'm thinking of an extreme amount of time. What would happen realistically? I mean, this is complicated shit. But when you break it down to the easy, it's easy to understand. But when it gets complicated, you do have to take longer than 4 seconds to know what's going to happen.
Sure. You know why this is complicated and it's hard to figure out? Because this whole thing is a contradiction. That's why you're having trouble. You're trying to hold two ideas in your head at the same time.
The other option is that we're all laymen who don't understand because we're not either capable or we have no interest or not enough interest in learning it. That's also possible.
The old
Sure, if you're a
special
technocrat,
boys argument.
if you're a
Openly admitted
technocrat
that you did not
bootlicker,
inform yourself about it.
if you're a
Actually, you
technocrat
did not even
bootlicker
try
who
to
worships
inform yourself
authority,
about it.
that might be a good answer. Yeah.
No, because reality and the universe, it's not obligated to make sense to us, to every single person. It's not obligated to be easy. It's not obligated to have simple understanding. There is no obligation for that. So if you don't understand something, yes, it's possible it's not real or doesn't exist or is a bad explanation. Yes, that's possible. But it's as equally likely or more likely that it is truly more complicated than we can understand. But it doesn't make it false. It just means that we're
not more likely.
interested enough
Incorrect.
to learn, or we can't make that connection for some reason.
You
But
guys
it
have
doesn't
been
mean
in here.
it's automatically false.
Yeah, your
because us
special
monkeys
boys
in this
argument is
Discord
trash.
channel do not understand.
Yeah, it's an appeal to authority and appeal to special knowledge, I think.
It's an appeal. It's an appeal to our egos. If you think your ego is too big, then you're
claiming only the special boys
say,
get to
I don't
know.
understand.
It's appeal to
therefore false."
authority.
No, that's
Right.
not an appeal to authority. Something is not concluded to be
logic.
correct just because an authority claims it.
It's appeal to logic
That's not.
and evidence.
It's simply a true statement that there is
No,
no
it's
inherent obligation for reality to make sense to humans. There's
That's
not.
fine. That is at its base true. But what I find interesting is this is a clear contradiction. What we're describing right here. You guys are saying that a contradiction such as this does indeed
Actually, no,
exist in
that
reality.
itself even isn't a correct statement. He's wrong. It is obligated to make sense. It has to make sense because we only have our senses, which means that's the only way we receive information, which means the only information we can possibly have is what we got from our senses. So anything that we have knowledge-wise has to make sense. Otherwise, it's nonsense.
Not,
Here's a
that's
really
not
good
what they mean, and
example.
you know it. You're once again playing with words.
Here's
Typical.
a really good example. I don't understand how car engines work. I can therefore make the claim that car engines don't work and don't exist because I personally don't understand.
Yeah, you can make that claim.
Look.
Okay,
I'm making the claim
you
that
are
cars don't
absolutely
exist. Cars
capable of
don't
making
exist,
that claim.
one,
Yes.
because I personally don't
And it's
understand.
just as silly as your.
Is there any validity to it?
Any validity to what?
To
Is
your
there any
claim.
validity? Is there any validity to the claim that car engines don't exist because I personally don't understand? Is that valid within reality?
That's up to you whether or not that's valid. Do you think that's
You're not
valid?
even being honest. You're not being honest
No,
at all.
validity is not a personal opinion. It's not.
Just
it's
because
not
an appeal.
Yes, it
just
is.
Because you don't understand
No,
it.
it's not.
That's
Your
the
appeal
only
to
way
incredulity.
it can
Not
exist.
Appeal to incredulity is not
factual.
it's not a good argument. Sorry. Just
Hey,
because you
Nancy
don't
Shill,
understand
you don't
it,
understand
doesn't mean
this.
it's fake.
You can't
I
fucking
understand
tell
more
us
than you
what's
do.
going on here. You
Listen,
can't tell us the
if you
solution to this
cannot
problem,
convince
can you?
You just
somebody
have
that
to- you
something
just
is valid,
reject
then
it.
it's not valid.
Hold
to
on,
them.
guys.
That-
Pay
you
Nessa
can't
Shill.
force them to
Give us
think
the
something is
answer.
valid. It's not possible.
Give us the answer, paid NASA Shill. Tell us.
42.
Yeah, that's what I thought.
Oh, so the 50-year thing. So that's still easy. If it takes the spaceship in that frame of reference 50 years, let's say 25 years to travel near the speed of light, and it goes an X distance based on that, and then it has to take 25 years near the speed of light to return to Earth, yes, 50 years have passed in Earth's frame of reference because of the time that it still takes in that duration of a trip. So you're going to be 25 years off from Earth at the maximum point. When you return, it still takes 25 years Earth time to get there, even though you're.
What if you
you're
stop for
traveling
a
out-
year
so
and
it's
come
still gonna
back?
be the same thing. Yeah.
No, that's what I asked. He goes out, right? And he comes back. I watch all this happen. I watch this whole thing happen. That means the trip that I watch in this rocket goes for 1 year. 50 years passes on Earth. So I have to see the Earth revolve around the sun 50 times by the time I watch this ship make a 2-year trip out here and come back.
Right. So what you're essentially saying is that time aging has still occurred. So if it takes that rocket ship let's say 1 year, it takes 1 year to get to the point where it's going to turn around. It has still taken 1 year for Earth aging and time to exist. It has revolved one complete revolution around the sun in that time.
Okay.
For that person on the ship, it has not been, or it's been, so it hasn't been 1 year in that moment. But when they turn around, they're going to travel faster through time, but it's still going to take 1 year to get back.
What
So
if you
another
stop for a
revolution-
year at the end of your
another
trip?
Another revolution has occurred on Earth. So the moment that it left to the moment that it came back, 2 years of Earth time has occurred, and it cancels out for the person because they've slowed it down at one rate and they've sped it up at the same rate, and it cancels out at that point. So that person on the ship has still aged 2 years according to Earth's frame of reference.
So you're
Yeah,
changing
so
it again.
you're wrong.
So the original thing was this ship leaves for 2 years, right? 1 year out, 1 year back. 50 years passes on the Earth, right?
No,
So
no,
I
I'm
watched
not
this
saying that at
ship
all.
for 2 years go out here and come back, and 50 years pass here.
No, I'm not saying that at all. What I'm saying is that the clocks will be sped up or slowed down accordingly. So if again you're on Earth and 1 year has passed and you've been watching somehow watching the clock on the spaceship, you would see it slow down by whatever rate. It would slow down during that time. So that person on the rocket ship has experienced less time at that point. When it turns around and you go another year and you're staring at this clock from the rocket ship, you're going to see that clock speed up tremendously. And that's how it's canceling out in the end, where it's, okay, he's behind us, let's say, 6 months. That clock has slowed down enough to where after 1 year, his clock is 6 months behind. Now he's coming back, and it's going to take a year to get back, but now we see his clock speed up, and essentially speed up by 6 months. In the end, we are now even.
So going one direction, speed up time. Going back the same direction, reverse time.
What a bunch of nonsense.
This is a change to the whole thing.
Okay, so can I explain the trick that he tried to pull just a little while ago? We moved off of it pretty quickly, but
Yeah.
I would like to go into detail to explain the trick that he attempted to use. Okay, with his example about the car engines and not understanding. So the discussion we're having is about a thing that we reject the possibility of, or we reject actually exists. We're starting from the premise of that's not a thing that can possibly happen. Okay, so he brings up another thing like car engines and saying, well, based on that, I can just basically make the decision that car engines, since I don't understand them, I can claim that they do these things or that they don't exist or don't work. Okay. And then he asks the question, is that valid in reality? The reason he asks that question, is that valid in reality, is because he already has an acceptance that the engines do exist and do what they're claimed to do. That's the basis that he's starting from. Okay, so it is not a comparable, it is not an analogy to what we're talking about. We are not starting from the basis of the thing that we're claiming doesn't exist actually does exist, like he was. He does think that the engines exist and do what they say that they do, what they claim that they do. He is starting from that premise. That's why he would ask, is that valid in reality? Because he wants the answer of...
Two experiments.
What's
I
that?
provided 2 experiments within the chat Brandon's aware. I explained one of them pretty thoroughly. I will find it
Listen,
again and
none of that matters. That's not important. That's not important to what I'm saying right now. The trick is you mention something that you accept does exist and then question, does it exist in reality? We're questioning whether or not something exists, and we're saying it doesn't exist in reality.
Despite
they
it
are not
existing
analogous.
in reality. It's the same
Listen,
principle.
you can walk over to a car engine and point to it and show that it does exist.
Right,
and then you can demonstrate it working. The thing you're talking about, you cannot do that with. They are not analogous.
Showing time
you
dilation.
accepted before you asked your question that engines existed. You did. Because that's why you asked your question.
Showing time dilation.
You knew before you asked if they were valid in reality. You already knew the answer to the question before you asked it. That's why you asked it. We are not asking the question from that basis. We're saying it doesn't exist in reality and then asking our question. They are not analogous.
All right, so I'm gonna be very clear. And if it's misunderstood, not my fault. There are two scientific experiments using different materials.
We're not talking about your experiments. I'm talking about your attempted analogy. No, we're not moving on to your experiments. No, we are not moving on to your experiments. We are addressing the false analogy that you just attempted to use. Now, accept that you were wrong, or we're going to keep talking about it.
Validating this theory.
It was not analogous. Do you accept that it was not analogous?
Because I'm ignorant. Okay.
Do you accept that it was not analogous?
That's the direction you want to go, that's fine.
Do you accept that it was not analogous?
Oh, no, it's 100% analogous because I have evidence.
Do you deny that engines exist?
Hold on.
Do you deny that engines exist?
You're gonna.
Do you deny that engines exist?
While I talk now, because
do you deny that engines exist? If you don't deny that engines exist, then it is not analogous.
I'm not obligated to answer.
You accept that they exist and then ask the question about their existence and their working. It is not analogous.
Keep after him. Keep after him.
I'm going to be very clear.
Do you accept that they exist or not?
Here we go. I understand what you're saying.
Do they exist or not?
There's no understanding. Keep after him.
Do they work?
You can keep asking the question. I'm going to continue.
I'm going to keep asking the question. Yes, I want you to answer it. I'm not letting you move on to something else in your conversation with me until you answer the question. Do you think that they do what they claim or not?
I understand what you are saying.
Do engines do what is claimed or not?
Oh, no, because I don't personally understand. Ready? Now I've answered your question. I'm going to move on now. Are you ready?
So you do not.
That wasn't.
You do not think that engines exist and do what it's claimed, right? Is that what you're saying?
Purely
based no. Yes.
On my
So he doesn't know what engines are.
Listen,
so
that's great. If you don't accept that engines exist, you are in the exact same position as we are, and you accept it as a valid position. Thank you.
I'll just wait for you to run out of energy. How about that?
It's a void position.
Run out of energy, dude. I got energy drinks for days here. You don't even know how many energy drinks I got. I got all kinds of energy. I got 5 different flavors and almost a full box on all 5. I am ready to go.
I'll let you get back to this, Bob, but I do want to hear BioDual.
All right.
I understand that you have 2 experiments that you've put in there, that the interpretation of which is that time is dilating. I understand that they have done an experiment and observe an effect and then interpret it as this is time dilation. I got that. We haven't looked at those in detail. We'll take a look at them. What we're showing you here is a logical contradiction to your claimed time dilation. And I know that you've come up with some explanation about slowing down and speeding up, which completely destroys the examples that we've been provided of time dilation.
No, it doesn't.
It does.
You fucked up this one. Anyway, listen.
What's occurring is that you're changing the rate of time. So if you're moving away from an object,
how many times do I have to hear this?
If you're moving away from an object that you're
make it succinct. Come on, make it succinct. Just give us the cut and dried. Come on.
I mean, I could. There is an opportunity to explain. But it's impossible.
Is it the same explanation that you given before? Because I'd rather hear Chaiki explain why you're wrong.
Yes.
Which would be I won't explain why he's wrong. What I'll ask you is the speed of light in vacuum equal to all observer?
quick question. Which would be the correct channel?
Hold on,
to
Chaiki just
post
asked a
something?
question, Morty, and then we'll come back to you. Chaiki, say that question again.
Is the speed of light for all observer in a vacuum, speed of light in a vacuum, equal to all observer? Is it
If all observers are stationary and or have the same motion and the same direction, same velocity, then yes, they would speed of light would be the same. Observably.
Is the speed of light equal to all observers? All observers means all observers.
I would
No
have
need,
to know.
no need for qualification.
Hold on,
just
Aaron.
called the observer.
Just let him answer.
It would be required to know the velocities of each observer because it would be different for.
Oh my God, bio.
I'm going to
Better
explain
not
what I
say anything. Better not
do. You
say
want me?
anything.
Frankie, do you want me to Google it and then copy paste the answer, or do you want me to
Yeah,
give you
sure,
my?
sure. Go ahead.
Which one do you want? Do you want me to Google it, or you want me to give you my opinion?
Google it.
Oh, okay, perfect.
All right, go ahead, Morty.
Yeah, Farming Ninja already sent me a DM.
Oh, okay. Okay, guys. Well, that was
I'm sending a
definitely
link with some context in the general chat right now.
So, is the speed of light measured by any observers different than the speed of light we know? Is there any observer that can measure it to be different?
Who are you asking, Chaiki?
The speed, no, you're right. The speed, no.
No. So the speed of light is equal to all observer, whether they moving relative to someone,
I would say yes.
whether they
I would
know.
say yes. I would
You
say
say
yes.
yes, then I'll ask you for your evidence. You can say yes
My
all day. It's like the
observation.
cars. It's like the
My
cars.
no,
I
hold
don't
on.
believe in
Chaiki.
cars because they
hold
don't
on.
make sense to me.
You asked
However,
me, I
cars
know, but you asked me a
exist.
question, and I
Listen,
said, okay,
listen.
why it makes sense to me? I
Cars
said
exist.
yes. I
So
said
go ahead.
yes. I
I'm
can
waiting.
measure the speed different than other observers, right? And I would
No,
say
you
my
can't.
position. Yeah, my
No,
position.
you can't.
Sure.
You can't.
Okay, well, let's get down to the
That's
fundamentals
the
of why
same
that
as
doesn't
cars.
work.
I can deny cars because they don't make sense to me. However, cars exist. The fact is that cars exist. What makes sense to me doesn't matter. And so does the speed of light. Doesn't matter your opinion about it. It's measured
Not my
to
opinion.
be
I
the
just said
same.
yes. I could
It is
observe the speed of
measured.
light differently than somebody else.
It
Of
is
course.
measured. No one have yet measured. And if you would, there's a Nobel Prize.
So
waiting
nobody's
for
measured
just
the speed of
the
light.
one
Is that what you're saying?
measured the speed of light in a vacuum to be different than the speed of light in a vacuum that everyone
Well,
knows.
that's why I think I could measure it differently just by my observation position. You know, that's all.
Go ahead. I'm telling you, there is a Nobel Prize waiting for someone who will measure
Well,
the speed of light, not to
no
be
one
the speed
has
of
and no
light.
one can measure the speed of light.
Let's go like this. Let's just be honest, right? The guys that did measure the speed of light had a position, right?
No,
You know,
Nobody's done it.
I don't
world
care. I don't care
and
about what
everybody
you
that's like,
say.
oh, we
I don't
measured the
care
speed.
unless you bring facts.
Right? They
Unless
had a
you
position, right?
Aaron,
have any
nobody
position you
measures the
want,
speed of light.
any position you want,
I know, I
and bring
understand.
us different measurement
I
to
was
the
wagging
speed
the
of
dog's
light,
tail over there. Sorry.
and bring us measurement to the speed of light. Until then, shut up. So the
Okay.
speed of light is measured to be equal for everyone. How do you explain this?
Where do you get that?
Logically.
Where do you get that
Logically.
fact from?
Shut up where I get it. It's measured.
Oh, it's measured.
Like
Okay.
Cappy.
Where did those guys measure it from? Wasn't
Yeah,
it
you can measure it in your house if you want.
Wasn't it a position of
No,
some?
no, you can measure it in your house. You can measure it.
Oh, so I can measure it. Okay,
Yes, you can. You can.
Wow.
By oscilloscope.
I was getting scared. I thought I
two
couldn't.
photodiodes.
No, you cannot measure.
All right, guys, I'm gonna cut it off there. It's 8:20. I hope that that was enlightening for you guys. Looks like there might have been some slowness to the stream at some point. If there was, I didn't notice, and I apologize, but looks like it's working now. Maybe it was just on my side. Anyway, that's neither here nor there. Okay, well, if this is all clear to you and you don't see a contradiction here, you will understand more than I do, or you've accepted more than I have, because this doesn't make any sense at all. This is a contradiction, in my opinion. Anyway, maybe we'll get a good answer over the next couple of days and keep exploring this issue. I thought we were done with it, but I just keep thinking about this stuff. The physical size of something reduces if you make it go at a certain speed, and if you're on it and measure it, it doesn't reduce, and it's just all nonsense. And I suspect it's just to make the mathematics work in some way. One of these days we'll figure out what they've done exactly, or maybe somebody has and they can tell us. But anyway, hope you guys enjoyed, and yeah, I don't know if there's anybody over there, Smurfer, but I can definitely look around or keep my eye out for you. I'm over on the other side of the state, but no bugs tonight, Gadget says. Cool. All right. Anyway, I'm blabbing on. Good night, everybody. We'll see you tomorrow night. Friday night fights. Definitely shouldn't be anything holding me back from doing the show tomorrow. So that'll be fun. We haven't seen Rumpus this week. Maybe he'll stop in and grace us with his pleasure. I do know that George, who I haven't seen much in the chat lately. I've been looking for him. Got something to say to him. Has been challenging Bev to a debate. Whether Bev wants to do that or not is up to him. But we'll see. Anyway, you guys have a good night. We'll talk to you later. Bye.